the day to one and all, our distinguished guests, ladies and gentlemen. I am Sonali Nanda. I work as Deputy Director at the Program Management and Authorization Directorate of InSpace, and honored to be your masters of ceremony for the day. To begin with, look around you. We are joined by some of the most brilliant minds and passionate individuals in the field of space. To brighten up the stage, I would like to invite Shri M. Ganesh Pillai, Dr. Anil Kumar, Dr. Prafulla Kumar Jain, and Dr. Manish Saxena on the dais, please. Thank you, sir. As the flowers cannot bloom without sunshine, no significant venture can truly flourish without the divine grace. To invoke that grace, may I invite the dignitaries on the dais to join together for lighting the lamp. Thank you. So instead of bouquets that fade, we believe in roots that grow. As a gesture of our warmth and respect, we would like to welcome our esteemed dignitaries. May I call upon Sri Vinay Paliwal and Sri Ravi Tulsian to do the honors, please. Thank you, Vinay and Ravi. It is said that coming together. Thank you. I'll be getting. Okay, so as I was saying, coming together is the beginning. Staying together is progress, and working together is success. Today, we have a distinct pleasure of coming together under one roof for this workshop on best practices and processes for safe and sustainable space operations. space object registration, frequency
This
identification,
meeting is being transcribed and summarized.
and ITU filing of satellite and launch missions. In this inaugural session, we have some wisdom-packed addresses lined up for you. We love to share and we love to talk. So to start with, Dr. V. Narayanan, Chairman ISRO, Secretary DOS, could not make it for this workshop due to his sudden travel plans, but he has conveyed his best wishes to the participants. Calling my first speaker, this person has prime responsibility to enable and facilitate Indian NGEs to use ISRO facility and authorize the space activities undertaken by Indian entities. Author of In Space NGP, a decisive manager, and above all, my boss. I invite Dr. P.K. Jain, Director PMA, to deliver the welcome address.
Thank you, Sonali. I think you don't need to introduce and such a flourishing words and all. Good morning to all of you. Shri Ganesh Pillai ji, Scientific Secretary ISRO. Dr. Anil Kumar, Director STRAC. So Manish Saxena, Director SSA and ITU ISRO Headquarter. Sonali, my colleague, Deputy Director in Space. All the distinguished delegates of this workshop who are present physically here, as well as who are connected through the YouTube link in the broadcast mode. My colleagues at ISRO headquarters, in space, the delegations and distinguished speakers from DOT, and also some of the delegates who have flown from outside India. Kevin is here from SES, Singapore. Ladies and gentlemen, it gives me immense pleasure to welcome all of you in this workshop, which I'm sure would be very useful for those entities who are planning to undertake any upstream activities, be it satellite or launch services. And when we talk about the upstream activities, two major activities under this category, which generally regulators worldwide make a mandatory requirements, are the space object registration and undertaking the interference-free operations. When it comes to space object registration, the idea is to ensure the safe and sustainable space operations. And similarly, the interference-free operation is ensured by the ITU through a mechanism involving ITU filing or the coordination processes, whatever is applicable. Now, as a regulator in India also, these two aspects, we certainly evaluate all the applications through this viewpoint. And we have also brought out our NGP, norms, guideline and procedure, providing all those guidelines are what are the factors which we need to consider. DOT also has brought out the guidelines for making the ITU filing by the Indian operators. However, still past with our experience of 2 to 3 years in processing the application, we still note that there is still lack of understanding in these two aspects amongst the applicant, especially those who are undertaking the space activity the first time, and which is resulting in a lot of multiple iterations and the delay in processing the authorization applications. Even to a certain extent, we have seen that some of the applicants have designed their system And then finally, they had to go back again to the drawing board because they had selected wrong frequencies either, or they were not able to meet the criteria for the safe and sustainable operations, which India has committed in an international forum, either through some of the treaties or the convention. So we thought that it would be a good idea that we have one workshop specifically for these two aspects and providing the practical demonstration. That would be quite helpful for the new entrant to the space sector in India. And with that approach, we contacted ISRO. ISRO is equally involved in evaluation of all these applications in terms of safe and sustainable operations, as well as ensuring that there is no interference to the Indian satellites. And ISRO readily agreed. We approached WPC. WPC readily agreed. And then they also kindly agreed to provide the resource persons for this workshop. So thanks to Scientific Secretary ji and ISRO leadership for agreeing to this joint workshop. And I'm sure this workshop would be very helpful for all of you. For the sake of those who are not able to attend today or not able to join even in the broadcast mode, we are recording this entire sessions, and appropriately after editing, this would be made available on our InSpace website for the future reference and the usefulness. So please enjoy the workshop, ask the questions as many as possible. There would be a separate question answer session, and hopefully this would be useful. Thank you very much. And once again, I take this opportunity to welcome you all. Thank you.
Thank you, sir, for setting the context. And this is a roadmap of why we are here. So we now move from why to how. Most of us know that SSA activities at ISTRAC is the backbone of missions operational safety. And it is fitting that we hear from Director ISTRAC himself, who has 2 decades of expertise in the domain of space debris, space traffic management, and SSA. Ladies and gentlemen, please welcome the person who is instrumental for declaration of debris-free space mission by ISRO. I invite Dr. Anil Kumar for his address.
A very warm good morning to all of you. Since Bangalore is warm now, and dignitaries on the dais, all my friends, close friends, Ganesh Pillai, PK Jain, Manish, and Sonali, and all other distinguished people gathered here from various industries. In fact, first of all, let me congratulate all the people who are assembled here from industries. From 2020, our space policy to when the space is open to the private industries, a lot of people jumped inside and started working on that. India in space knows more than 300, 400 space startups are there. And most of the people are venturing out to space, spacecraft related things and launch vehicle related things. And as already PK Jain said, actually for getting the authorization, we require to satisfy some of the things, criteria. Actually, in fact, in India, it is very, 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 very diluted. If you compare it with FCC, America, whatever we do, whatever they do, the format, if you see, it is too tough to fill up. Here we faced actually this 2020 itself under DSSAM, Directorate of Space Situational Awareness and Management in ISRO headquarters, which I was heading. We started preparing the requirements for space debris mitigation and to get the authorization for that. On that basis, what are the things to be addressed? That format actually we prepared in 2020. 2021 time frame, it has undergone so much reviews. Later, when InSpace has accepted that, and that also, so much thought and so much reviews have undergone for that, clearing that authorization format. Once industries are getting into it, when they fill up, they faced a lot of problems, especially with the orbital propagation, dynamics, orbital dynamics, spacecraft evolution, orbital evolution, lifetime, and also post-mission disposal activities of the spacecraft and launch vehicle upper stages. So they found very difficult because these people are not expert. They don't have the expertise of filling up, especially with the orbital dynamics things. Then they started coming to InSpace, and in turn, InSpace used to send to us. Later, this DSSAM has shifted to ISTRAC. That is called Space and Sustainable Operations Management Area in ISTRAC. So there it used to come this format, and our people who were doing that, especially Dr. Bulbul Mukherjee and team, now she is heading that area. That team used to find out a lot of, they had to do a lot of analysis and support these people. And how to fill up. Many times when the first draft of the filled form contains a lot of inconsistencies in incompatibilities. So she was telling actually 2 years back itself, we had to have some meeting with the people to tell them how to fill up the form. Thanks to Dr. P.K. Jain, he has taken it very seriously, and we found a lot of issues. That is why now we called all the industries to tell and what are the things inside, why it is required. Many things are there, many questions are there, why it is required. You know, when I started my activities in 2000, that is 25 years back in space debris related things, exactly I started in 2001. I started the working on space debris. Before that, I was doing something in my VSSC. Earlier, I was working in VSSC. 96 onwards, we were doing something about some black box of a space object collision avoidance, etc. But actual real study started in 2001. Then last 25 years, ISRO has done a lot of activities. Wonderfully, they have executed many things on SSA related activities and STM related activities, including we are satisfying all the international guidelines for space debris mitigations. What are put forward by the IAD's Interagency Space Debris Coordination Committee, which was later accepted by the United Nations, UN Corpus, UN Space Debris Mitigation Guidelines, which has come in 2007, I think. All those things ISRO is satisfying now. And we are trying to do it. And that has to be done by all industries also, private industry also, because liability comes on Indian government, what are the launch activities happening from India. So what are the presently 7 guidelines of the UN mitigation guidelines, and also later now what is coming up in the long-term sustainability guidelines of 21 guidelines. We have to satisfy that, comply with that, as other international agencies doing, other countries are doing. If you take NASA, ESA, JAXA, many other people, and China, it is not known fully, Russia is not known fully, but these other countries, they have done complying with all these guidelines meticulously. Accordingly, they made their authorization format, registration format. Even if you know that a lot of large constellations are coming up, like SpaceX, Starlink satellites, Google, OneWeb, like that, many things are coming up. These are all adding complexity to the space activities. And we should not get into any problem. Once we may be spending, usually I used to tell that we may be spending small amount for a spacecraft. Suppose 50 crore we spend on a spacecraft and launched it, or 100 crore we spend on a spacecraft and launched it. Its utilization is so much valuable. Once it is in orbit, its cost, the function, whatever it is doing, the data, whatever we are getting from them, its cost is enormous. If you lose such a satellite in the orbit, there will not be any replacement for that. It may be either maybe for civilian purpose or maybe strategic purpose also. So losing a satellite in the orbit is so bad that we lose not only satellite losing, data losing, not only national interests are not saved, but we are losing huge economic impact is there for that. So it is our duty to safeguard our satellites in the space. That is first thing. Second thing, if it happens, if it is collides with some other satellites, it will add up the issues, complexities, because a lot of litigations will come up. Not only that, when two satellites collides together, number of fragments generated will be so high. It can be hundreds, thousands. That will add up, it will make the environment, our space ecosystem totally unmanageable, unsustainable. So such things to be avoided. That is why these guidelines are given. As you know, all of you know, there are no legally binding rules as of now. There is no space traffic management rules as of now. But every country has to put their own conditions, restrictions, and they have to comply with the international guidelines. If it goes like this, it's very simple. I will tell you 500 kilometer to 600 kilometer, we will not able to use further. So many constellations, so many objects are there already in that orbit. And that is the best, most valued orbit also for LEO. For almost all remote sensing activities, almost all strategic activities, if you count any activities related to the low Earth orbit, the most valuable orbit is 500 to 600 kilometer. But now that has already become totally clouded thanks to SpaceX. There are so many things are there. Now, as I said, when I started in 2001 time frame, there were only about 10,000 objects in the space. The cataloged objects, that is more than 10 centimeter sized objects. At that time, number of operational objects were about 550 to 606 percentage, 5 to 6 percentage. Today, number of objects in the space more than 10 centimeter cataloged is close to 40,000, nearly 50,000. Number of operational objects in the orbit came already about 12,000. 25% are operational objects. When our operational objects is there in the space, to manage our satellite without colliding with them is very, very, very complex. We have to coordinate with them. If a space debris coming close to my satellite, I can maneuver myself and be happy that I saved my satellite. But another operational object come close to my satellite, I cannot maneuver my satellite because they may also maneuver. So it may be double impact will be there. That is why we have to coordinate with them. Coordination is an extremely tedious job. And mostly this collision threat comes very few hours or very few days back. It comes 24 hours prior if I get an information that it is coming close to an operational satellite. How to coordinate with them in 24 hours? Mostly, most of the small satellites, identifications are not our contact IDs may not be there. So it is a difficult process. So that is why we should have a system, space traffic management system, at least not to regulate, at least to bring all the details about the spacecraft. Who is to be contacted in emergency? What is their email address? What is their mobile number? And what agencies this is there? What is the objective of the satellite? What is the size of the satellite? These information should be available. Already UN is having a registry. There we are regularly sending the things once in 6 months. I think once in 6 months we are sending it. Okay. So what are the operations? We are doing it. So it is necessary for us to get all the informations. Then recently 2024 we have declared one DFSM debris free space mission initiative intent for all Indian space objects, people, whether it is national agencies or private industry, they should satisfy the criteria given in DFSM. What we generally say is that by 2030, we will abide by all these guidelines. There will not be any satellite or there will not be any rocket upper stages which is not abiding by the international rules. So what is to be done for that purpose? We already initiated the process, DFSM process, why in the satellite design itself, in the launch vehicle design itself. So anyway, Dr. Bulbul Mukherjee will be spending telling more about that. So this is much awaited meeting of all industries to give us feedback on why it is important, how to fill up the form, what are the benefits of doing that, all those things to comply with international things. Let me wish all the very best. Let me thank InSpace and the team from ISRO headquarters, Manish Saxena and program office, and Dr. Bulbul Mukherjee and the team from ISTRAC. And also I know that afternoon ITU filing, the details are there. We have experts here. So let me thank each one of you for doing this workshop for all our Indian industries. Thanks a lot. All the very best for you. Thank you.
His wisdom has truly illuminated the complexities of SSA today. To deliver the inaugural address, I am honored to call our next speaker, who is primarily responsible for overseeing policy, planning, and program coordination at ISRO, A true technocrat, ladies and gentlemen, with experience in strategic management and operationalization of project and programs. I am privileged to invite Shri M. Ganesh Pillai, Scientific Secretary, ISRO, for the inaugural address. So,
A very good morning. Dr. A.K. Anil Kumar, Director ISTRAC, Dr. P.K. Jain, Director Program Management Authorization in Space, Dr. Manish Saxena, Director SCNPO ISRO Headquarters, Ms. Sonali in Space, Sri Amit Gulati, Joint Wireless Advisor WPC, and dear colleagues of the dais, and I am very happy to see a lot of young faces here. So very, very happy because our space community is growing and it's getting younger and younger. And so it's my pleasure to speak to you today at this workshop and on the best practices and processes in the space sector. So as you are aware, the Indian space program started with a very modest beginning in 1962 with a very tiny rocket lifting off from Tumba. That's a southernmost state in Kerala, in small village actually. And from there, it has grown over the years to become a vibrant and multifaceted program that is highly respected in the global community of nations today. The Indian space program was driven by ISRO, with the industry playing a supporting role uh, till recent times. In the year 2020, the government, under the visionary leadership of Honorable Prime Minister Sri Narendra Modi ji, announced the space sector reforms, enabling industry to play an independent and end-to-end role in space sectors. This was followed by the formation of InSpace and the release of Indian Space Policy 2023. All these initiatives have created a new era in Indian space sector in the past few years. Today, we see the emergence of more than 370 space startups, many of which are present in this hall and many of them are joined online also. And they are driving the innovation and enterprise in this sector. We also see enhanced participation from Indian industries. Now coming to Chairman ISRO Secretary DOS, Dr. V. Narayan has always been a very keen supporter of NGs in this space endeavor. He has visited and interacted with many space startups. He has devoted considerable amount of his time and effort to provide proper guidance and mentorship to the startups and NGs. He is very keen to attend this workshop and was following up with me about the arrangements of the program, etc. However, due to the last minute exigency, he is not able to attend today. However, he has conveyed his best wishes and has mentioned that all support will be provided for. Many of you must be in the process of conceptualizing or executing space missions of your own. It is very pertinent to note that space is a difficult and unforgiving domain, and you need to carefully take into account all aspects from the beginning itself. I am sure you are being ably guided by the experts from ISRO and InSpace on various nuances of space mission. Among the various aspects of space mission, the topic related to safe and sustainable operation, object registration, frequency identification, and ITU filings are of great importance. With the increasing use of space technology, the space is becoming very congested. As on date, there are more than 30,000 known objects in the low Earth orbit. In the previous year, 4,600 space debris were added with 315 successful launches. This is almost 1.5 times of the previous year. Therefore, the risk of collision are no longer hypothetical. They are real, immediate, and potentially catastrophic. The cascading effect of debris generation poses a serious threat to long-term sustainability of space. Recognizing the threat of space debris, ISRO has taken significant steps towards building indigenous space situational awareness. SSA encompasses the capability of detect, track, and predict the movement of objects in the space. This is necessary to ensure the safety, security, and sustainability of space operation. The NETRA, Network for Space Object Tracking and Analysis project, reflects our commitment to safeguarding national assets while contributing to global space safety. These efforts mark an important transition from being users of shared global data to becoming contributors and potential leaders in SSA. In the year 2025, more than 1.6 lakh collision alerts have been issued for our satellites. We have carried out about 140 collision avoidance maneuver so far. Even on the lunar orbit, there have been need for carrying out collision avoidance maneuver for Chandrayaan-2 orbiter. This shows the importance of having capability of processing close approach alerts and taking timely and informed decision to mitigate collision risk. So you have to be aware of the space environment when you have a space mission of your own. Moreover, your own operation should not cause difficulty to other operators. Accordingly, you should take steps to ensure sustainable operation of your mission. It is prudent to build in such capability in the design stage itself rather than as an afterthought. We have announced debris-free space mission, which aims to achieve debris-free space mission by all Indian space actors, government and non-government by 2030. Spearheaded by ISRO, the required measures are adopted in design and mission management, such as provisioning of sufficient fuel for end-of-the-life disposal, incorporating trackability, identification, maneuverability, etc. India also encourages all state space actors to follow this initiative for long-term sustainability of outer space. Proper registration of space object is also very important so that your object is recognized in the United Nations registry as an Indian object. Now coming to the ITU filing, frequency spectrum and orbital positionings are crucial as the resources that are finite, valuable and highly contested. The International Telecommunication Union provides the platform and framework for the regulation and coordination. The framework is enabled through filing the satellite network with ITU. Even the most advanced satellite system needs timely and strategic ITU filing. The principle of first come, first served underscores the importance of foresight, coordination, and speed. If you look at geostationary orbit, this is a lot of competition for acquiring the orbital resource. The geo arc of 40 degree to 120 degree east is ideal for India as it provides good visibility over the country. In this arc, there are around 460 filings in 115 orbital slots. More than 130 satellites are operational. These filings are and satellites belong to 31 countries. The MEO and LEO orbits are also having cutthroat competition due to the emergence of large and mega constellations. You as a space aspirants need to have an understanding of the regulatory framework, including ITU procedures, spectrum coordination, and compliance requirement. You have to be mindful of the choice of frequency for your mission so that you cause minimum interference to others and successfully carry out your spacecraft or launch vehicle operation. I'm happy to see that large number of industry participants have come to attend this workshop. I also underscore that there are equal number of participants. I understand that there are a lot of participants online. I hope you make full use of the opportunity and obtain maximum knowledge and insight through the interaction today. Sharing of knowledge is the foundation of success. ISRO has been known for this culture, and now InSpace and ISRO are jointly carrying forward the tradition. I wish to compliment the experts from Department of Telecommunication, Amateur Radio Group, and from Department of Space who will be conducting the training sessions today. In conclusion, the future of space is not defined solely by our ability to reach orbit, but by our capacity to manage it responsibly and smartly. Space situational awareness and ITU strategy are not isolated domain. They are integral to our vision of becoming a leading spacefaring nation. I hope that with this workshop, you will get insight into these two important domains of space regulation and sustainability. From Department of Space, I assure you of our continued support and guidance in every effort of yours in the space sector. Best wishes for the workshop and for the future. Thank you. Jai Hind.
Thank you, sir, for official inauguration of this workshop. So to wrap up this inaugural session with grace and gratitude, I invite Dr. Manish Saxena, Director of Satellite Communication and Navigation Program Office, to propose a formal vote of thanks.
Thank you very much. It's my privilege to be here with you all today to register the vote of thanks. Let me begin with thanking Secretary Department of Space Chairman ISRO, who has always been guiding and leading the space sector, and especially in this era of reforms, for supporting this program and providing his guidance for today's workshop. Let me thank Chairman in Space for being a firm supporter of the space sector and for ably guiding and leading this workshop today. I wish to thank the Scientific Secretary, ISRO, Shri Ganesh Pillai, for sparing his valuable time and being with us for the inaugural session. Thank you very much, sir. I wish to thank the Director of ISTRAC, Dr. Anil Kumar, sir, who has been a veteran in this field and also has been very enthusiastic to guide us in curating this program. Thank you for your time today. Dr. P.K. Jain, who leads the PMA team of InSpace, has been working very, very hard to make this program a success. Thank you very much for sparing your time and effort and coming all the way here for this program. I wish to thank the senior officials from ISRO headquarters, Dr. Behra and the other officials from ISRO headquarters for being with us today in this program. The senior officials from InSpace, the senior officials from ISTRAC, Dr. Bulbul and her team for coming here for this workshop. Let me thank all the faculty who will be delivering their sessions today. And with a special thanks to DOT official, Shri Amit Gulati, and the AMSAT official who will be conducting their sessions. My gratitude to you and also my best wishes for your session. The highlight of the program today is all the participants, you all, because we are all here today for you. You are the reason for us being here. Thank you very much for coming down to Antariksh Bhavan ISRO headquarters and then spending the entire day with us. Some of you have also traveled from different places. So thanks for the efforts for coming here. Thanks to all the online participants also for spending the entire day on this workshop, and wish you all the best for this workshop. Lastly, I wish to thank the directorates of the ISRO headquarters, led and represented by the Scientific Secretary, the administrative staff of the ISRO headquarters, led and represented by the Associate Scientific Secretary and Director Administrative Service, and also the CISF for lending support for the conduction of this program. Thank you all. Wish you all the best.
So before we let the aroma of tea and coffee pull us away, we have one very important mission, group photo. So may I please request all of you to go outside from the auditorium and assemble near the steps with your best smiles ready. We all are coming there. Thank you. Please note that we will reassemble at 11 now for the workshop on safe and sustainable space operations. So please don't be late. Thank you. Okay, 11:05. Thank you. is reserved for space and sustainable space operations workshop. At the end of the session, a 15-minute slot is reserved for question and answer round. Online participants, please scan the QR code on the screen to ask your questions on the Slido interface, and we would take them up appropriately. Our first talk will cover the basic concept of SSA and its importance to counter space environmental hazards, space debris mitigation measures, and India's debris-free space mission initiative. Will also address future challenges and basic requirements to conduct space operations in a safe and sustainable manner. I invite Dr. Bulbul Mukherjee to deliver the talk. She is Deputy Director, Safe and Sustainable Operation Management Area at ISTRAC. We will call it as SSOMA. For nearly 2 decades, she was involved in spacecraft operation and management, and now she is primarily responsible for consulting SSA-related activities and is pursuing various efforts to meet long-term space sustainability goals. Over to you, ma'am.
For the introduction and a very good morning to all. So, slide changer, please. So, in this talk, I would like to give you a brief introduction on the basic concepts of space situational awareness and sustainable space operations. So, coming to space situational awareness, first, let us understand what situational awareness is. It is something which is integral part of an integral part of our day-to-day activities, and in fact, it means that you should have a overarching awareness of your surroundings, and that helps us to plan our activities in an efficient manner. In fact, situational awareness is not just something which only the humans have. It is required for even the animal species, so that they can be they can evade any kind of predatory attack. So it's something which is pivotal to survival. So same concept when we extend to space, it becomes space situational awareness. Basically, you need to have knowledge about the surrounding environmental hazards and take there is an element of forecasting involved in it, because basically you collect the data, you make sense of it, have a perception of the dangers which are there, make assessment of the future risk. Basically, you are able to forecast the situation or how the situation will evolve. So that there are two major elements involved here. One is nowcasting and second one is forecasting. Now let us see the space environmental hazards. First is the hazard which arise due to energy and particle flux that is always present, and this can actually have certain detrimental effect on your onboard electronics, and even on the in case of any kind of solar flares or any other events which governs the space weather environment. I think there is a feedback. Maybe I'll just remove the polar mic. Am I audible to all? Okay, so let's go like this. So space weather is something which is primarily governed by sun's activities. And if there is a solar flare, that has two kinds of effects. One is it expands and hits the upper atmosphere. So the atmospheric drag changes, and also it makes even astronauts and other spacecraft electronics more vulnerable to upsets, because the background charge increases. Natural objects are also there, asteroids, comets, and others. And the most important part of the hazards are the space debris, or the which comes under the artificial objects. These are unwanted objects which have been left in the orbit and not removed or disposed properly. They comprise the upper stages left, which are of the launch vehicle, these defunct satellites and their fragments. And they pose two kinds of risk. One is the hypervelocity collision risk, because these objects, when they are in space, they travel at a really high velocity, couple of kilometers per second. Just to give you a perspective, at low Earth orbit, around 600 kilometer, the velocity will be typically 7 kilometer per second. And if you are in a geosynchronous orbit, it will be typically 3 kilometers per second. So any collision can have the potentially catastrophic effects. And also there are another risk it poses when it re-enters the atmosphere. The objects which are in the lower altitude and eventually have their orbit decayed due to various effects of other perturbations, like primarily dominated by the atmospheric drag. And once they re-enter, during the intense heating it faces at the upper or denser atmospheric level, denser atmospheric layer, it can still survive. Some of the components can still survive and actually impact the Earth. So this is another risk which the space debris pose. And therefore, the bottom line is with the now opening up of different opportunities, and there are diverse actors getting into the space domain, because after all, space-based activities have brought us unmatched or have reaped unmatched economic and societal benefits. So everybody wants to leverage that. And that is the reason the number of objects are increasing, and there are it is becoming more and more congested. Certain regions which are more conducive above, it is usually effect will be catastrophic, because the impacted object will be completely destroyed. If the object size is smaller, even then it can cause mission-ending damages. So the characterization shape and size is very important. And finally, you need to predict how the objects trajectory is going to evolve in future, so that you can take the mitigation action and avoid collision. So that is another aspect of space situational awareness. So just to see the cataloged versus non-cataloged debris. By cataloging, what we mean is the object is, a particular space object is observed well enough so that they can be uniquely identified and disambiguated against the other background objects. So typically this size of the cataloged objects are more than 10 centimeter or so. And you can see, I'm not going to read out, but these are the kind of damages it can cause. And 10 centimeter also kind of is the limit up to which object can be tracked by ground-based facilities. Usually for low Earth orbit objects, which extend from the Earth's surface to about to 2,000 kilometer altitude. That is the most highly utilized space regime, and there most of the operations satellites operated. So it is designated as one of the protected zone by Interagency Space Debris Coordination Committee. I'll talk about that agency later on. And there is another highly utilized region, which is geostationary Earth object, Earth orbit. So that is also a highly utilized region. So any kind of debris generation or unwanted object, leaving any kind of unwanted object in this kind of region is not a good idea, because they are kind of can pose collision threat to other operational assets. So these are kind of called protected zones. Now, if you want to see an object within the LEO region, the best deal is to use radars, powerful radars, so that you can get the echo signal back from them. And especially for debris, they are all dead objects. They do not emit any signal. So only thing is you need to have some sort of passive way of monitoring them. One is radar. Another way of monitoring them is through optical telescope. When the object is sunlit, we can actually see the object, and we are at dark. It is possible to see the object with an optical telescope. And that is actually more useful for, or traditionally more suitable for observing objects which are at geo altitude. For geo altitude, the distance is too much, so radar signal becomes very faint when you try to see anything. So I have just shown you the how the size of the objects, and for different regimes how this kind of observations are made, and there is between 1 meter to 10 centimeter. There, these objects cannot be actually catalogued. You can observe them, but you cannot distinguish them and assign individual numbers to them. So this is the place, unless the object is catalogued, you cannot have their orbital prediction in the future, and you cannot take any kind of evasive action to avoid any kind of collision. So basically, below 10 centimeter and 10 centimeter to 1 centimeter, this is the most gray area where object knowledge is not known, and these objects are too big to be shielded against. You can put some protective shielding to make sure the impacted object doesn't cause the damage to the critical components within the spacecraft. This region is also not possible, and they are too small to be evaded by any kind of collision avoidance. So this is one gray area which we need to deal with if we have to operate in space. And another thing which we have to be aware of is the space debris surround the entire globe. So you have to have a really large network of sensors in order to collect this kind of data and continuously catalog them and update their knowledge, orbital knowledge, and have a precise prediction of their orbit. So this kind of network is not right now, is not there in India. It's the most comprehensive SSA network is owned by the US Spacecom, and most of the data is sourced from that US Spacecom maintained. There is a spacecraft portal from where. Now, I'll just talk a little bit about the guidelines for space debris mitigation. As I've told that they're really something which is posing a serious threat to operational assets. Now, mitigation means it helps to contain the proliferation of debris and in certain measures which are doable or rather cost effective. So foundational guidelines were actually provided by the Interagency Space Debris Coordination Committee, which was formed in 1993. And this is an agency where all the national space agencies are member of, and ISRO has become its member in the year 1996. And 2002, they came up with these guidelines, and which were later on adopted by the UN Corpus in 2007. The UN Corpus guidelines are the most high-level guidelines. They do not specify any kind of numbers or anything, whereas IDC is more technical in nature. Then this the next level of more technical guidelines are ISO 24113, and I hope there was a session on ISOs where this were covered in detail. And these guidelines are actually translated by different space agencies into engineering practice according to their national interest. And I've just listed some of them. You have this NASA's guideline. GMR is the JAXA's. ESA has one guideline, French Space Operations Act. GOST is the Russian one, and QZ3211, this is the Chinese guideline. And recently we have also released something called India's Intent for Debris-Free Space Mission, which was mentioned by Dr. Anil Kumar during the inaugural address. And now just to look at the guidelines, it's kind of very simple, and I've put it in at a top level. First thing is we need to limit the generation of debris when we are doing the operations in space. That is, we do not release unnecessary objects. If there is a lens cap or something, it better be tethered to the main body. Then avoid any kind of on-orbit collision. Basically, you be aware of your surroundings. If any object is coming and you know they're likely to collide with you, it's better that we maneuver or we adjust our trajectory in such a way we can avoid the collision. First of all, we lose our assets, and it's like, you know, a traffic a collision on road. You not only you damage your car, you damage probably another operational satellite, and you also create debris. You kind of choke up the traffic, so you create problem for the rest of the space traffic as well. So that is something which is totally undesirable and should be avoided. And minimize on-orbit breakup. Basically, what happens is during the initial days of space flight, people used to, even now, people keep some extra guidance margin in the upper stages. And once the satellite is injected, those extra propellant also remain on the upper stage itself. And they continue to orbit the Earth in an uncontrolled environment. There are thermal gradients, and there can be punctured by some meteoroid. As a result of that, what happens is the stage self-explodes, and that adds to the fragmentation population. So that happens for the objectives, you remove the object from the operational or protected zones, which the two zones which I have mentioned earlier. So if it's a low Earth orbit, you bring it down so that it gets into the denser atmosphere and its orbital lifetime becomes less. And when it re-enters the atmosphere, it should be also done in a way that its footprint or the debris footprint should not fall over the populated zones. It's better to make them re-enter on over sea or uninhabited zones. And third one is this post-mission disposal of geosynchronous orbit. There is no, at geo altitude, there is no atmosphere. So only way you can remove it out of the geo-protected zone is to go up in the supersynchronous orbit. So just again, to reinforce the reason we are talking sorry, it will take a lift of time, so that this I think I'm not able to go to the next slide. Please. Yeah. So post-mission disposal, this is, I've already talked about what is needed. And here for geo, we go up to a zone which is supersynchronous orbit. And this, how much altitude we should be raising above the geo belt depends on the kind of spacecraft characteristics, because there are certain perturbations, especially due to the solar radiation pressure and moons and sun's attraction, that can make the orbit again come back and encroach into the protected zone. So the orbit should be sufficiently moved away. And the basic guideline for IDC is make sure that it is doesn't come back within the protected zone, at least within another 100 years. And for LEO, the best option is to directly retrieve, but that is a very expensive option. And as I'm not aware of whether that has happened. I think there's something is wrong with the slide transition. Okay, sorry about that. So what it means is you make sure that your impact point on the Earth is within an uninhabited zone. And if control reentry is not feasible, the best thing you can do is to at least make sure that your orbital lifetime is limited to less than 25 years. But now the norm is even with 25 years lifetime limitation, we are not able to, slow down the growth of the space debris. So it's advisable to make it as short as possible. And passivation is another requirement, which is a removal of all kind of active energy sources. For launch vehicle upper stages, it is required to remove this kind of any kind of pressure and gas and other things. And for spacecraft, this has to be followed by, this is usually done for geo satellites right before decommissioning. You remove all the turn off all kind of rotating devices and discharge your batteries and burn the excess fuels. And I've just shown you this is a fuel dump spiral, which is typically done at the end after injection of the satellites. The excess fuel is vented out, and it creates this kind of tumbling motions. And some people mistake it as gets mistaken thinking it's a UFO or something. And this is the kind of vent nozzles which ISRO uses, so that when they vent the fuel, there is no change in the altitude. And just to show you, this is for this passivation of upper stage is our regular practice for ISRO satellites since 2002. And in 2001, there was a breakup of PSLV C3, which actually accelerated the adoption of such practices. And I'll not dwell much upon this deorbiting aspect of LEO objects. This is Cartosat 2. This was the first satellite which was deorbited for ISRO. And you can see we did almost more than 30 maneuvers. And there are some, it had happened, there are some gaps, that is because of COVID-19. And there were some certain experiments which were done to observe the onboard autonomy and other aspects. And you can see here, there is one particular maneuver which was done on 5th of November in between. That is to avoid any kind of one potential collision with ISS when the orbit had already decayed around 400 kilometers. We'll talk about the reason for doing so and the requirement for having maneuverability in my later slides. And this is one of the experiment where controlled reentry was attempted for megatropics. Here also we did make the satellite go down all the way with perigee deboost. And there was one particular maneuver where we had actually raised the perigee just to make sure that the impact point passes over the southern, over the deep Pacific Ocean. So you basically need to adjust the trajectory so that the impact happens over deep ocean or somewhere which is not inhabited. And here is one more example of microsat. Here what happened was this satellite was actually in a very low orbit. It would have already been compliant with 25 years as well as 5 years, but it had lots of propellant left. So that is the reason the deorbiting was done. And at the end, the rest of the fuel was expended by conducting out of plane maneuver, where only the inclination was changed. Now, the reason I have shown all these slides are just to impress upon you that this is an elaborate activity. It needs to be planned as a properly manner, and then only it can be achieved. Similarly, upper stage deorbiting is also done for PSLV because those stages are restartable. And this is a couple of examples where this was made to re-enter. And for GSAT, this is a geosynchronous satellite. Here, what is done is their raised apogee and perigee are raised progressively all the way up to minimum requirement is at least 235 plus some 30 kilometer, almost like 270 kilometer. Here they were raised almost up to 350 millimeter or almost 400 kilometers. So this was in perfect compliance with the IDC guidelines. Now I talk a little bit about the long-term sustainability or the notion of it. Basically, what it means is sustainability is one of the buzzwords you must have come across. What it means is you should have the ability to sustain space operations and meet the correct requirement of the current generation, as well as make it available for the future generation to utilize it in a sustainable manner. So that requires certain level of foresight. You cannot be short-sighted and just focus on the long-term goal and get into the problem of what is known as the tragedy of commons. This is a common term some of you may be aware of. When you have a shared resource and everybody uses it without due regard or consideration to other people's requirement, finally the resource itself gets totally depleted and nobody else can use it. So this is the thing which we need to be aware of. And that is the reason in UN purpose, there is a 21 guidelines on LTS, which has been adopted in 2019. These are some of the major highlights. I'm not getting into the details of it. The reason we talk about all this is that whatever we do, whether it's a sustainable operations or anything, SSA plays a very key role in that, because you need to have this kind of all the awareness to make sure that your operations can be can proceed in a sustainable manner, and it has a very strong forecasting component also. So you can have long-term prediction of the environment and again tailor your operation in a way that it will become more future-proof. And debris-free mission operation was something which we mentioned earlier, and this was the statement. Basically, all the actors, all the Indian actors should be abide by these guidelines, which I will talk about now later. Here you can see there are a couple of things, but whatever are in black, they are already covered within IDC. Here, first two are already known, and then avoid on-orbit collision and breakup of satellites. And basically, here the compliance requirement for post-mission disposal is more stringent, given the rapid rise in the background population. So here what we exactly mean is that for orbital life of rocket bodies and the low Earth orbit satellites, which are left in or any kind of orbital stage, which are left in geosynchronous transfer orbit or GTO elliptical orbit, and transiting the low Earth orbit should be less than 5 years. And there are also special considerations made for the human spaceflight safety. That is basically what we mean is there are particular region in 400 kilometer plus minus 30 that is more conducive for human spaceflight, because it allows less radiation hazard and short time, and the atmospheric drag is not too high so as to ask for frequent orbital maintenance maneuver. So based on that, the region is the most suitable one, and even our Gaganyaan mission is going to be there. So that is one place where we should not be polluting and creating unwanted debris. If you are first-time venturer, better to avoid that region to the extent possible, because with a small satellite, if the object is not properly tracked, it can cause undue threat to one of the crewed mission. That is something which we want to avoid at all costs. And there are also ensuring trackability, observability, and other things which will basically what happens is when you launch a very small size satellite, it becomes more and more difficult to track from ground, even with powerful radars. And there are so many objects, and one radar will not be always dedicatedly tracking unless you have your own facility. If it is tracked by US Spacecom, they will not update your TLEs very frequently. So the threat will not be known to the other operators, and it can lead to a situation which is totally undesirable. And avoid spacecraft mission extensions without doing a critical analysis of the fact whether the object, this kind of mission extension can jeopardize or can compromise the ability of post-mission disposal. Because what happens is most of the time satellite payload will be operating fine, but there will be other critical systems like attitude control systems, sensors, actuators, which will degrade to such an extent that it will not be feasible to, or even the fuel will get fully depleted. So it will not be possible to do any kind of post-mission disposal. So that is something which we need to avoid. I think I will take some more time. No, I will take some more time from my other colleagues because I'm covering some of their part. Yeah. So capacity building is for other space object tracking. That is something indigenous capacity which we need to build up, and of course pursue all sorts of innovative efforts to even when we are constrained with many things, probably that is the time which actually becomes a more incentive to pursue some innovative techniques. So I'll just, as I'm approaching the end of the presentation, so these are some of the emerging challenges which we need to talk about. One is the proliferation of the large constellation of satellites. That is something, first of all, it causes certain congestion in certain orbital area. And you can see how the object population has changed. There are some large spikes in certain orbital domain, and it is kind of dynamic. And this becomes whenever any object or any launch vehicle has to rise and go to the upper any kind of orbit, like let us say 600, 700 kilometer, you have to necessarily transit this kind of orbital shells. And some of the shells are planned to be deployed at a very low altitude, below something like 320 to 340. So those belts are also becoming very, very congested. And what I've shown here is a launch vehicle lift-off time. This is basically the launch window. Whatever is marked as red are the zones where you cannot lift off. Greens are the ones within the launch window where lift-off is allowed. You can see there are hardly anything which is left open. Everything else is closed because of this large constellation. This is just a simulation results only with Starlink satellites, generation 1, generation 2, not considering debris, not considering other populations at all. So this is the situation. And there are other limitations or other concerns due to this dark and quiet sky. This is also a big issue. Basically, it totally mars the images which are acquired by optical sensors. And for small satellites, there are other issues, like they're difficult to sometimes track and identify individually, especially when launched in a batch in rideshare. And most of them lack the maneuverability or any kind of propulsion systems because they're very small and meant for technology demonstration. The biggest problem is there are no contact details sometimes available. And on many of the satellites are in the public domain, the dimension is given something, but when you actually check, the actual dimension is something else. So that totally changes the scenario of risk assessment and mitigation. And this failure proneness is also another limitation which is associated with small satellites because they mostly use COTS component. So this is the general concerns for spaceflight safety. First of all, the orbital data, whatever is available for the list of the space objects, are not always accurate. There are certain data gaps, especially for small debris. And sometimes people use SSA provider data, and they also try to fuse it with the data which is available from US POSCOM. They're not of the same grade of accuracy. It creates different kind of problems. And especially there is no rules of the road right now. As they have mentioned, there is no proper space traffic management, and it is unlikely to evolve unless people, they themselves figure something out through mutual understanding and goodwill. So, and interoperator coordination is right now, there is no proper mechanism except for through snail mails. That really creates problem because people who operate in different time zones, you shoot a mail today and you will probably get the reply after 4, 5 hours or 6 hours, whether you are really having very close to the conjunction. That creates different kind of problems. So this is just to tell that IS4OM is one place where we do all these kind of activities. And the last one is we always try to do some sort of hand holding and awareness raising about the new space actors. So I come to the end of my presentation. So what is really required for doing a space safe and sustainable operations are you need to have certain minimal awareness or minimal knowledge about astrodynamics. Otherwise, you will not be able to fathom the level of complexity or the kind of problem you are going to encounter. And you need to be familiar with space laws of policies. Minimal familiarity is needed, and understand the national regulatory requirements as well. And also there are certain standards, CCSDS recommended, CTM, OPM, all these kind of standards are there. That should be known to all when you're trying to operate in this dilemma, in this kind of domain, so that it doesn't, you can easily interact with the rest of the space actors. And while selecting the orbit, try to choose options or try to choose orbits which are already known to be less crowded. Do not try to avoid to the extent possible getting into this kind of inhabited region. And there are certain design level considerations. Anyway, we'll be talking about this in more details, and basically have some kind of mechanism through which you continuously monitor the space weather events, because they do have a bearing in the operations which you carry out. So that will be all from my side. Thank you.
Thank you, ma'am, for delayering the subject for the audience. It was very meaningful, isn't it? The next presentation is by Mr. Amit Khandari and Shri Madhav Nakani. Amit is Group Director of SSOMA and Project Director of Project Netra, ISRO's maiden end-to-end SSA system. He leads the team providing operational support to space object proximity analysis and collision avoidance activities in ISRO. Madhav is a mechanical system engineer turned space policy professional. He has studied aerospace engineering, space and telecom laws, and is currently pursuing his PhD. He is working as an engineer at SSOMA. Over to you guys. Amit is coming. Okay. So requesting to speak on the mic. There has been some audio issues online. Thank you.
So good morning, everyone. Thank you for that warm introduction, and thank you to all of you for turning up. And we have approximately 30 minutes. So what we would be doing is we'll be talking about some recommended best practices for deploying satellite and undertaking launches. In between, I would be asking my esteemed colleague Amit sir to join, where he will be dealing about the operational approach. And then I would take over again for the next 3 slides. All this we will try to cover in the next 30 minutes or so. So I promise this is the only slide which I have jam-packed with all the information which talks about the regulatory aspects of working in a space environment. So let me use that screen. I think that would be better for me to speak from here. So we have ratified and are signatories to 4 international space law instruments. The 3 which are relevant ones are the ones I'm talking about here. The first one is the Outer Space Treaty. The Outer Space Treaty wants national responsibility for space activities by non-government actors. What this implies? It implies authorization by IN-SPACE. That's what all of you are required to do before carrying out with any space activity. The next one is the Liability Convention, which makes the state liable for damages caused by state activities. So again, what does it imply? It implies IN-SPACE to have the full chain of custody for monitoring your activities from launch to end of life. And that is what IN-SPACE does post-authorization. The last one is the Registration Convention, which requires us to maintain a registry of space objects at UN, and by us, I mean the country, India. And what it implies to you, it implies that the state should have the jurisdiction and control over the space object, even your space object. So that entails that there should be the determination of the onus of registration. Even when we are giving you the authorization for doing the space activity, it should be determined that in whose registry the space object is getting carried. So these are the 4 international law instruments. The normative frameworks, which are not binding international law, but they are as good as soft laws, are the UN long-term sustainability guidelines, which are required to be regarded as a responsible space player on the global stage. We have the Debris-Free Space Mission Initiative, which my esteemed colleague Dr. Bulbul Mukherjee mentioned in her slides. And IS4OM is the nodal entity, which again she had mentioned, and we work closely with InSpace to ensure safe and sustainable operations. The key regulatory requirement is the compliance to space sustainability. And what we want you to do, we want you to fill up a pro forma, which has to be filled at the time of authorization of space activities. The next few slides, we would be discussing about what this pro forma requires you to do. And the presentation is organized in such a way that it has 4 parts to it. We talk about the best practices for launch vehicles. Sorry for that. Yeah, so we talk about the best practices for launch vehicles. We talk about the best practices for satellites. We talk about the best practices for choosing orbits. And then we talk about the best practices for operational measures. Right. So all of this is contained in the norms, guidelines, and procedures, and specifically chapter 11 of the document which has been released by InSpace. So any information which you feel that I am skimming through here, you can of course refer to that document which has everything in detail. So let us go step by step. The first way is the best practices for launch vehicles, which is covered under chapter 11, sections 3A and 3B. So it's all words, but I have tried to give it some pictorial form so that it is better comprehensible. The first one is FMECA assessment, specifically for orbital stages. We want you to do a comprehensive failure mode analysis, specifically for the orbital stages, because these are the ones which can break up and create unwanted debris. We want you to do launch collision avoidance analysis. Again, one slide was covered by Dr. Bulbul Mukherjee in the previous slides to ensure that there is a collision-free liftoff time which is getting selected. There should be additional safety considerations for transit through the inhabited zones. You have to do a perform survivability and ground casualty risk assessment when you have re-entering orbital stages or the suborbital stages, which would be typically your final stage of your launch vehicle. And avoid orbital stages with solid motors wherever feasible, because again, these are the ones which can break up and they can create unwanted debris. The next one is when you are doing something with multiple satellite injection, which ISRO typically does and which we also want the private launch vehicle players to do in future. You have to design the separation sequence in such a way that there is a less close approach risk among the separated satellites and the upper stages. It is self-explanatory. It sounds a lot easier, but it is not. But that is something that you need to comply with. You have to deorbit the uppermost stages after injection of payloads to minimize the long-term presence. Carry out controlled re-entry of orbital stages to a safe impact point, wherever feasible, to minimize the on-ground casualty risk. And of course, passivation of all upper orbital stages to minimize the risk of accidental explosion. The spiral is what was shown by Dr. Bulbul Mukherjee in her slides. So best practices for satellites, let us go one by one. So we want you to provide basic details about the satellites, the overall size, objectives, maneuvering capability, perform failure mode analysis to assess the risk of on-orbit failures, explosions, breakups during the operational phases, ensure sufficient fuel budget for post-mission disposal operations, design consideration to minimize debris creation during the operational phase as well as passivation. There should be cybersecurity protocols, including encryption at design level, unauthorized commandeering of satellite, maneuvering capability for satellite with the largest face area more than 0.1 meter square. This is again based on global best practices. And satellites should be capable of being tracked and be uniquely identifiable, which is especially important for small satellites. Right, so we discussed the best practices for launches, we discussed the best practices for satellites. Now let us talk about the best practices for orbit selection in which you are planning to put your satellite. So during the mission planning stage, we want you to determine collision risk based on the background space object density during the transit, injection, and the nominal operation phase. This risk is determined for the entire lifetime of your satellite, which my colleague Mr. Soumitra will be covering in the presentation after this. The cumulative collision probability should be less than 1 E minus 3, 1 in 1000. Please select mission orbits. Avoid selecting mission orbits, which are known densely populated orbital regions, and where the human spaceflight missions are operating, which Dr. Anil also mentioned in his plenary talk, or expected to traverse through the inhabited region. You should have maneuvering capability. When we talk about operational safety, which is in section 3D, You have to adopt a process for regular on-orbit conjunction risk assessment. If it sounds like a mouthful, the next speaker, Mr. Amit, would be discussing about what is this on-orbit conjunction risk assessment. Use the best possible data available on space objects for conducting conjunction analysis. Estimate the likelihood of collision in terms of the probability of collision. Flag critical conjunctions. And once you have flagged the critical conjunction, you should be able to plan and execute a collision avoidance maneuver for which your satellite should be maneuverable in case of consistent critical close conjunctions. If the secondary object is an active satellite, do coordinate with the operator so that only one of you will be maneuvering. Yeah, he will be talking. Yeah. And document relevant procedures, provide such information during application submission. So now I invite Amit sir to talk about the operational practices for collision risk mitigation. This builds entirely upon the previous slide, and he would be taking over from me.
Good morning. I would be covering the operational practices for the collision risk assessment. So, what is a conjunction assessment? Basically, it involves propagating the orbit of a satellite sometime in the future to say when it comes close to some other space asset. When we find such a close approach, we try to evaluate the risk of collision, and then if we find the risk to be significant, we try to do a maneuver to go out of the way. So why this is required? So there are multiple reasons for this. The first thing is that all of us have to, in the future, have to operate in a very, very congested space environment. So unless you have this capability, you would no longer be able to operate in such an environment. The second thing is, for human space missions, this becomes extremely important because the risk involved in those missions are much more higher. The third point is that if you want space to be sustainable, you cannot have collisions in space, like what was told about the Kessler syndrome. Okay, but this looks easier on the face, but there are a lot of challenges involved. What are the few of them are listed here? The first thing is that you know that the number of missions are increasing, and when that happens, you will have a lot of alerts coming to you. So as you, if you look at a much lesser volume of alerts, you may miss something which is very critical. But if you take too large of them, you'll be spending most of your time just to try to do this analysis. First part is that. The second part is that there is an inherent orbit uncertainty. For example, if you see the cigar shaped structure there, the egg shaped structure there, you see that there is a. Do I have a pointer here? Have a laser pointer here? Sir? Pointer? Where is it? No. Yeah, so if you see the thank you. So what I was trying to show is the X-shaped structure. There you see that there's a small dot in the middle. That dot is the best estimate of where our satellite is. And the particular egg-shaped structure along that shows that where the satellite can be. So the center of the ellipsoid is the best estimate what you have, but it can be anywhere inside that. So now when you have that uncertainty, how do you say that it is going to collide or not to collide? So the point here is that whether two space objects are going to collide is not a simple yes or no question. It also needs some kind of probability computations that I'll try to cover in the next slide. Okay. The third thing is you have to cross-validate the results. Now, why do you have to cross-validate? Because you cannot take a decision based on a single point. Unless you have a repetitive analysis which says that this is a risky conjunction, you should not take any action based on a single data point. Okay. The last thing is that if the operators are active, then you need to coordinate. As was also told by Dr. Anil Kumar and Dr. Bulbul Mukherjee that if you don't do that, you may actually increase the risk of a collision. Okay, so we go to the next slide. So summing it up, there are three parts to it. One is C has basically three parts. The first part is screening. The second part is your risk assessment. The third part is the making of decision. Okay, so we go to the first part. Now, this is a typical satellite in 536 kilometers orbit. Okay, and it is a sun sync orbit, a very, very occupied zone. So if you see, I try to find out how many objects are within 20 kilometers of it. When it traverses an orbit, you will see a lot of objects. To see the first part of a lot of green dot structures. Now, what I do is I come back to how many objects will come to close to it if I make armin less than 10 kilometers, right? So I make a distance equal to half. Now you see the thing is the thing is the number of objects are drastically reduced. Now how less you can go? Should I make it 5 kilometers? Should I make it 2 kilometers? Should I make it 1 kilometer? Maybe 50 meters? So as you go, as you decrease the threshold, you will have less and less number of candidate objects, but you will be getting a lot of false negatives. Like you may think this thing is very safe, it might not be so. If you have too big a window, you will have too many objects, but most of them will be false alerts. So you have to make a balance between what is your screening threshold. So the next slide is I will just be covering a few terms of how do we estimate risk. Now please understand that the close approach distance was a geometric distance. What it said was the proximity. It was not telling you about the risk. Proximity is not risk. There are two separate concepts. Okay, so let me talk about this now. When you see the so when you see those two arrows, you see two circles. You see two objects there, primary and the secondary, and those two objects are at a missed distance. So we are at a particular time, at some point in time, those objects come closest to each other, and the distance between them is r min. Now the two circles there are basically showing what is called the hard body radius. I'll come to that why it is that, and the big ellipses are there the area of uncertainty. Okay, so why you represent them as spheres? The reason is that if there are two objects, this can be in any orientation, right? So to make sure that you are able to accommodate for the worst case scenario, you have to have a sphere around it. So when you make a sphere around it, you make sure that whatever be the orientation, it will be somewhere along the sphere. So for the two objects in the picture, you make two such spheres. And to make the things mathematically simple, what you do is you make a super sphere of that. The super sphere is called the combined hard body radius. So in a perfect world, if we knew everything about the orbit, if the distance between the two objects was less than the combined hard body radius, it would be a collision. As simple as that. But the actual world is not so simple. So what happens here is that you have to take the uncertainty, and if your uncertainty volume is not touching at the cat, then probably there is no risk of collision. But obviously we don't take a 1 sigma value. You actually scale it up to 3 sigma or 5 sigma based on your requirements. So you're talking about the probability of collision. So probability of collision is basically a mathematical concept which combines your hard body radius, your uncertainty, and your close approach distance to give you a single number which you can use for determining the risk of collision. So we have covered both the proximity as well as the risk in the last two slides. We'll go to the next slide. Okay, so this is basically covering of how do we do the the collision assessment. So there are basically 3 points to it. The first part is you identify objects. I showed in the first slide. The second part is that if you find the risk to be above a particular threshold, you decide to go for a CAM. But if you go for a CAM, to avoid one object, there is always a chance that you will have a secondary risk because of that OM, orbit maneuver. So what you do is you make sure that when you do a collision avoidance maneuver, you do not cause any secondary collision threat. So that is the third part. So every time you change the orbit, you have to make sure that you are not getting into path of something else. So point number 3. So there are two objects involved. One is the primary or asset, other is the secondary. So how do you know those orbits? The orbit of the primary is basically the responsibility of the owner or operator. Whoever owns the satellite has to know about the orbit. The secondary orbit has got multiple sources. In the earlier 2000s, the source used was two-line elements, TLE, which is not recommended now. Now there is also called as a SP catalog, or the HAC, or the Special Perturbations Catalog, which is much more accurate. And also many operators like Starlink and many other operators, they share their ephemeris in the public domain. So the higher the accuracy of the ephemeris, the better you have a chance of estimating the collision risk. Okay, so this is the last, this part shows very clearly. The top portion is the owner operator, which gives us the operational ephemeris of the spacecraft, the maneuver plans. The below part is the CSPOC, from where we get the secondary operator data. So we get the orbit, we assess the thing, and then send the recommendation to them. So that process runs every day. Okay, so we'll now come to the last part, how do we decide a CAM? So if the risk of collision is substantial, I will define the word substantial in the next slide. So you have to do a propulsive maneuver. Okay. So what are the risks involved? So to a LEO spacecraft, there are two things. One is the geometric distance, 100 meters. The second is the probability of collision, which is 5e minus 4. So if you have a chance of this 5 in 10,000, you go for a collision avoidance maneuver. For a geo satellite, if any geometric distance comes less than 2 kilometers, we recommend a CAM. However, after performing a CAM, you also confirm it with the latest orbit determination that what you did actually made the risk situation better. Okay, which actually improved the situation. So sometimes in the LEO orbit, what happens is that you have a mission orbit, you have a sun sync orbit, you need to have a particular ground track. When you do a CAM, you shift out of the ground track. So after that, you have to come back to the main track. So that also is required. So sometimes after CAM, you may have to do a maneuver to come back to the orbit thing. So it is always better that you try to combine CAM with a regular orbit maintenance maneuver so that you don't waste fuel and you don't go out of the orbit track. Okay, these 4 parts. So how do you do CAM? There are basically 2 different things. One is the radial maneuver. So in radial, what happens is you go up and down. So this maneuver is typically done half orbit before the conjunction epoch. Other is a tangential distance. You make sure that you don't reach the wrong time at the wrong place at the wrong time. So what you do is you basically shift your times. So basically, the earlier you can come to a conclusion, the better it is, because you'll not waste much fuel. So the closer you go to it, you may require a fuel which is 10 to 20 times more than the nominal thing. The next one. So this is other thing. You can just see the situation now. So before the CAM, the primary and secondary were quite close. But after the CAM, the distance went up. The closest approach went up. So this is the typical timeline for the conjunction assessment. So you may have a risk 5 days before, but you cannot take an action 5 days before because you may have a lot of uncertainties. Maybe the drag, maybe it is not properly tracked. So what you do is you try to make sure that all the alerts are pointing in the same direction. There should be a particular trend. So once you are affirming that this is really a risk, then you go for a maneuver. The maneuver decision is taken sometimes between 12 to 24 hours before the actual close approach point. So 12 to 24 hours is a sweet spot in which you don't spend too much of a fuel and you are also sure that you're not doing a wrong maneuver. So next one, can you go please? So this is I have selected over a year. What you see is that the alerts can come much before TCA. So some alerts are sudden, which come only 1 day before TCA, a time of closest approach, and most of them come 4 days before. So you have about 4 days to decide, to analyze, reanalyze, get new data to find whether it is really a threat or not. And the end point is for geosatellites. For geosatellites, because there is no drag, so you can get 7 to 8 days before also the alerts. But for most of the LEO satellites, you get to get alerts 3 to 4 days before the actual event. You go to the next slide. So this actually sums up my presentation. So basically, as I said, CA is basically the screening between the primary and the secondary. A risk assessment basically converts all your close approach distance, the probability distribution, and the size of the object to a probability. So the mitigation involves a modification of the path. So that basically you increase the distance, either a radial or tangential, to reduce the probability of collision. It is highly recommended that you do a check to make sure that it is not a single point aberration you are seeing, and you are seeing a total pattern. So as the event develops, it is always better to have more and more data. The later, the better the data, the less the uncertainty, and the better the estimate of the probability of collision. So basically, if you do too early a CAM, you have to make it very conservative to make sure that you take care of all the uncertainties. But if you do it very close, half hour before, you have to have higher delta B. The value may go be 10 to 20 times more than an earlier decision. So with that, I conclude my slides. Thank you.
Right. So thank you, Amit sir. And I think this slide now makes much more sense. We discussed about assessing on-orbit conjunction risk assessment, likelihood of collision in terms of probability of collision, conducting collision avoidance maneuver, and relevant procedures that you should document. This I would take not more than 5 minutes in this. We are just talking about best practices, what we discussed over the previous 4 things for launch vehicles, satellites, selecting an orbit, and operations. And this is what we want you to do. You should frequently intimate to InSpace. In the first place, intimate about your launch date, liftoff timings, nominal injection parameters of the spacecraft, and any changes that might occur in this. Post-launch, within 1 week of injection, please let us know your injected orbital elements within 12 hours. The NORAD ID, which would be designated to you by US Space Command, the predicted ephemerides, inclusive of orbit acquisition maneuvers, and any off-nominal performance or anomalies that may have occurred during the launch. Post-launch, periodic notifications, preferably every 6 months, the orbital details, controllability aspects, maneuverability aspects, how good or how bad they are working or not working, the fuel availability, and the change in mission objectives, if any. Again, all this is available in Chapter 11 of the norms, guidelines, and procedures. Critical close approaches that you see with other space objects require special high priority immediate notification. There should be event-based declaration when there is one of these happenings or maybe multiple of these happenings, the change of ownership, orbital migration, critical system failure, loss of control, loss of maneuverability, end of life, post-mission disposal. Right. So before I call Mr. Soumitra to talk about the next part, we would be spending some time about ephemerides. So what we say when we want you to regularly share the ephemerides is, operational ephemerides of your satellite should be shared with InSpace, because this is the most accurate way of knowing where your object is. Ephemerides is derived from the Greek word, and it is nothing but a time-sorted table of your position and velocity, basically the state of your spacecraft. And any planned maneuver, you should share the expected ephemerides during the burn and after the maneuver. Keep updating it at least once in 3 days. Do share with us the updated ephemerides once in a week if it is a LEO object. For GEO object and in high Earth orbits, maybe if you share within a week, that is also fine. How this ephemerides and other aspects of debris mitigation, that would be discussed by Mr. Soumitra. With this, I would like to end my presentation. Thank you.
Thank you, Madhav and Amit. Very well coordinated presentation. Proceeding further, the next speaker is Shri Soumitra CVSS, who works in Observation System Group of SSOMA and specializes in radar systems. He contributes in the realization of multi-object tracking radar at SDSC SHAR. He is an avionics graduate, studied space and telecommunications law, and is working in activities related to SSA capacity building and space debris environmental modeling. There are 2 parts of his presentation. Under part A, he, along with Dr. Bulbul Mukherjee, will present the procedure to fill the proforma, which is required to be submitted as part of registration and authorization. Under part 2, he would present the tools which are required for the technical analysis to generate the responses of the queries in the proforma, with a focus on NSA debris assessment software and NASA's debris assessment software and ESA's debris risk assessment and mitigation analysis tool. Over to Soumitra.
Thank you very much, ma'am, for that kind introduction. In this presentation, we will go through the pro forma, each field by field, and we are seeing many places where we understand that the intention of the field, what we are asking is not known. So we will try to clarify that, what we are asking and why we are asking that, so that you will be able to fill the pro forma in a better way. You can go to the next slide, please. So these are the general guidelines. I'll just skim through this. The main thing that I wanted to tell you, a couple of important things that we wanted to tell you here is put all the supporting analysis in separate annexures in the pro forma. Try to keep it as simple as possible, and maintain consistency in responses across queries. Please don't. At one point, please don't give in grams, and at another point, please don't give in kgs and things like that. Please do avoid that, and try to use proper SI units. This. Can you go to the next slide, please? Yeah. So the pro forma has 3 parts to it. One is the general information. In the general information, the main information that we are seeking is to your contact. Whenever if there is a collision, we have to contact you. You give us a contact which will be responsive anytime when we are going to contact. That is the main information from our side that we are seeking. The other 2 parts will go in detail, the mission related information and the space situational awareness related information. We'll go to the mission related information next. So in this, the mission objectives, here we don't expect you to give the complete your mission objective and how it is going to cater to your company growth. We are not expecting that. We are expecting what is in which area your mission is going to be. It is Earth observation, it is communication or space science or whatever that is. Is it an experimental satellite or? Yeah, it is in a very, very short description is what we are looking for. And we don't want you to go through the complete details. And next, we want the spacecraft dimensions, like already mentioned, Amit Kandare sir in his presentation, he told we have to compute all the drag, all the collisions have to be in future. So we have to find out what is and there is hot body radius as well. So we have to find out what is the dimension of the satellite in different conditions, since we are authorizing now. And like Madhav had already mentioned, the onus is on the state. So we have to know at whichever stage of the satellite, if it fails, we have to know for how long it will be in orbit. So we want the stowed condition, the dimensions and post-deployment dimensions. And if you are going to control the attitude of the satellite, we want the drag area from your side, which you are going to maintain for the satellite, and the SRP, solar radiation pressure area, which you are going to maintain. This is very much required, and we see some inconsistencies in almost most of the pro formas which we are receiving. And we need the mass, obviously. So if your satellite has a maneuverability, we need the dry mass and the wet mass as well. The intention is for, again, the same thing. What are the PMD activities which might be required, whether you have catered that in the propulsion system which you are going to use. And we want to know the type of propulsion system, because when it comes to passivation and other PMD activities, so we have to know whether you are actually taking care of that. And if you are not taking care of that, we would advise you to please take care of that. And we'll go to the next slide, please. And in 9, we will ask for if there is any hazardous material. This is only for safety assessment report while handling for improper to address any improper handling. Coming to the number of payloads per satellite, we want you to tell us what is the number there. It is only a number that is required for us to keep track of the hosted payloads. And we need the ownership details of the payloads and each payload configuration and architecture and payload TT&C, telemetry and commanding frequencies. For each thing, we need reasons for why we are asking this question with these details. For the payload configuration, we actually need those details because when we are doing the passivation of satellites, the payload should not have any energy left in them, which might cause an explosion of the satellite, which might lead to more debris. So we don't want that. And when we are giving permission, when we are giving authorization for the hosted payloads, we will look if they are taking energy source from your satellite bus, or whether they are having their own energy source, or whether they are keeping some fuel for some experiments, or whether they are taking fuel from you, whether they're controlling or any other aspect which might have some energy source there. And of course, the same thing goes for TTC frequencies as well. We want to check any interferences. What you are saying, if there is any miscommunication between you and the hosted payload, we don't want the state, India to be responsible for that. We want to identify that beforehand. We'll go to the next slide, please. So next, coming to the satellite, or if you're keeping a constellation, we want the configuration, architecture, and mission profile, and things like that. And trackability. This is where most of the things that we are seeing are very much misaddressed the actual intention. So when we are saying trackability, when we are talking about how we will know the position of the satellite, not any other thing. When we just want to know where the position of where the satellite is at any point of time. That is what we mean by this field trackability. So when we are asking how you are maintaining, what is the maintenance of observational data, we are not talking about your scientific data which your payload is collecting, or any other Earth observation data your payload is collecting. That is not what we are talking about. We are talking about the how you are tracking your satellite and how you are maintaining the data, where you have the tracked data, how you are maintaining the data for the satellite. We are not talking about any of the payloads, any of the scientific observational data, payload observational data there. And we are asking for any spacecraft ephemerides data. This is something I have skipped in the initial guidelines, because people are not understanding the difference between an ephemeris and TLE. So satellites' position can be informed in many different ways. TLE is one of the way, which is not very accurate, which we cannot use for conjunction assessment, as I already mentioned. Ephemeris are exactly knowing the position of the satellite at any point of time. So if you are getting an ephemeris data from any GNSS or any other instrument which you are placing in the satellite to know its position, so how are you planning to maintain that data, and for how long you are planning to maintain that data? After mission life, or after mission life, how long you're planning to maintain that data. So if there is somebody after your mission life, the satellite is still in orbit, and somebody claims that your satellite has come and hit me, so we need to have some kind of data to cross verify that. So after mission life, how much data, for how many days you are storing the data and keeping the data, that is what we mean here. And unique identifiability, like some beacon or some retro reflector or any other physical features or electronic features where we can uniquely identify even after the mission life. That will be useful to track the data, track the space object, and do tracking data association in an easier way. We'll go to the next slide. Right. Yeah, so, sorry, ma'am. Oh, yeah, sorry. Yeah, so here, wherever we have, I forgot to mention this, wherever we have filled in the response field, wherever it is in blue color, these are the kind of responses that we are expecting. We don't want you to copy this and paste it again. For your mission, what is the kind of response that we are expecting? That is what we are saying here. We'll go to the next slide, yeah. So here we are talking about the orbital regimes which you are covering through your operation. If the specific requirement is there for your mission, where you have to go through different operational orbits for conducting the experiment, then we want you to enlist all the orbits here. Like it is already mentioned, and it is actually given in the registration pro forma itself, try to avoid 400 kilometers manned space orbits identified for manned space missions, inhabited missions. Again, that is very much required. If possible, for any experimental missions or anything, please choose an orbit which is lower than 400 kilometers, and it will not be any threat at any point. And next we'll go to the ground segment. I think most of the pro forma in itself is very, very self-explanatory. I don't think we have to go through that again. And then we will go to the space situational awareness related information. So here we are asking expected in-orbit lifetime. We have seen a pro forma where the mission life was 12.326 years or something like that. We are not expecting that kind of we are not expecting that kind of things. So if that is how accurate your mission life is, try to give it in days, weeks, months. Please don't give 12.236 years or something. Please give it in an integral form. Yeah, give it as an integral values so that it will be easier for us to analyze. And do not use approximate values. Don't make 10 years, 15 years. That is not what we are expecting, or 15 years, 20 years. That is not what we are expecting. Try to, if it is 15.5 years, try to give it in months. That's okay. 15 years, 6 months is fine for us. Next, coming to the post-mission life till atmospheric re-entry. This is applicable only for LEO space objects. And this is what you have to compute using proper tools here. So we expect it to come within 6 months. That is not a proper answer. 6 months, and the detailed analysis can be attached as an annexure. So coming to the total number of objects released during nominal mission phase. If you are doing something like an experiment like SpadeX or something, we want the list of objects which you are going to release, and at the orbits at which these objects are being released. And generally it will be nil unless you are doing a docking experiment or something like that. And in the 17, quantification of collision risks. Here we are talking about both large objects as well as small objects. Here we will first address the large object. How to do it, we will discuss in the next presentation. But here we'll first discuss about large objects. You should not use TLEs for doing this. This is for your entire mission life. That means some 5 to 6 years or whatever your mission life is. You cannot use TLEs beyond 7 days. So even then you are not supposed to use TLEs for collision assessment, like Kandari sir has mentioned that multiple times in his presentation. So please do not use TLEs here. These are not expected to be done with TLEs. These we have to use proper tools for conducting this, and then so you have to use collision space object population density models, and then we have to do how to do it and how to compute it. We will see in the next presentation. Yeah, and these are required during the design phase, so that if your spacecraft, if it is big enough, it might need some maneuverability, and you should start searching for it at the initial, you should start planning for it at the initial stages of the spacecraft. You cannot design a spacecraft and then think that this might be a very big risk mitigation, but I don't have any fuel. You cannot do that. Try to plan for it ahead during the design phase, not during the operational phase. Or of course, you change your orbit so that the risk will be less than 1 in 1,000. We can go back. Go to the next slide. Yeah, so if there are any plans for regular conjunction assessment, you have to do. Minimal requirements for space flight safety need to be met here, sorry. Next, here in 18, we are asking for the source of orbital elements of other space objects. That means the secondary space like just now you have heard Kamit Kandari sir, where he was telling ki our primary satellite needs to, during a conjunction analysis, we have to see if our primary satellite is coming close to any other secondary object. So where are you sourcing your information of secondary object from? Maybe you are a very rich company and you could be sourcing it from Leo Labs or some other provider who can give tracking data to you. That is the intention here. So usually it is SpaceTrack, which is freely available for most of the players. So you can that is the best available data of other space objects. If you have any access to any other available data, you should use that. Like just now, Amit Kandari sir has mentioned that Starlink publishes all of its satellites ephemerides openly and publicly for your utility. If it is possible for you to use, you have to use that data, not the TLE data. Next is agency owner or operator for who will be responsible for conjunction assessment. So here, some of the satellite owners could be giving this out as a work order to some other agency which can provide conjunction analysis. So that is what we meant. Ki who will be the responsible for operate? If nobody is there, then operator owner should take the responsibility of doing the conjunction assessment of the space object while it is in its orbit, whether it is in mission life and after that as well. But at least during the mission life, you should take the responsibility of conducting the conjunction assessment and seeing if your object is coming close to any other object. So if you have given it to outsource this to some other company or something, you have to mention that here. And plan for sharing ephemeris for collision avoidance or conjunction risk mitigation with the US. Of course, you have to share the data with us. We are seeing here ki everybody says that ki they will share the data once in 3 months or once in a month or once in a week. It's been years, nobody has started sharing the data. We cannot keep following you up again and again. We want you to take this up and take that responsibility while you're launching a space object and try to share the data with us as you have committed it. We are not asking you to commit it, but if you are committing it, please do share the data. If you have any orbital maneuvers or other things which nobody else will know, it is better if you can share the data as much as possible, like I already mentioned earlier in the space sustainability as well as conjunction assessment presentations. Now we'll go to the next slide. Yeah. So here maneuverability, whether you have any maneuverability, what is the means of propulsion that you are using, these and all are required. And of course, the fuel budget which you are using for orbit maintenance, for collision avoidance, and for any post-mission disposal which you have allocated. This field is required and you have to do this analysis beforehand. So for authorization, we will see whether you have done the analysis, enough analysis or not. For this, when we are giving an authorization, if your space object is really posing a threat or is in an orbit which is already crowded, we want you to take care of these things, and we want you to do an analysis and to take care of these things, where you allocate certain fuel for collision avoidance and certain fuel for post-mission disposal. And of course, planned for orbit during mission life notification, any planned orbits, we have already seen, any planned orbit maneuvers have to, it is better if you inform us to us. We have kept it as an option because there might be certain trade secrets and other things which you may not want to share with us, but you have to share with us for space sustainability point of view. It is expected to try to avoid the information which you are going to share, at least share the position and the trackability so that we will know okay, where your satellite is. If somebody contacts us saying that your private satellite so-and-so has done an orbit maneuver and has come close to us, we should have some kind of whether it has actually done the orbit maneuver or not. So we need this data and try to share the data and try to protect your IP and all those things, but try to share as minimal data, but try to share the position as much as you can. And regarding the PMD, I think this I asked Bulbul Madam to explain. Thank you, sir.
So as we have already mentioned that post-mission disposal is one of the most important measures for mitigating space debris. This is actually, this is space debris mitigation guidelines. This is in general what the requirements are. So earlier I had mentioned there are 7 guidelines which will be applicable to you. That is, first is the intentional release, limit the generation of debris. So there should not be any intentional release of debris objects. This is one of the standard response. And another was there should not be any intentional destruction of the satellite. That can be also mentioned as one of the points where you are complying with the internationally accepted guidelines. Then FEMCA should be done to ensure that there are no failures which can lead to explosions or any kind of generation of debris. That is basically to minimize the risk of accidental explosions during on-orbit operation. This is one point. Collision avoidance capability should be there. And even what we come across is most of the applicants think that just because they don't have any active propulsion, they need not do anything about collision avoidance or conjunction assessment or any kind of activities related to space flight safety. That is not correct, because it's like this. Suppose you have a vehicle and its brake is failing. At least what you do is you shout and tell other people that, look, I can't maneuver, you go out of my harm's way. So that's the kind of responsible behavior which we expected from you, at least to make sure that your lack of propulsion status is known to the other operators, and also you engage with other operators whenever this kind of conjunctions happen. I can tell from our experience, there are many occasions when we are receiving mail from other operators of other countries, which are actually CubeSats, and they explicitly tell that I cannot maneuver, your satellite seems to be in conjunction with our assets, so you please take care. So this is the minimal requirement which is expected from any of those who are not having propulsive capabilities. Then the another thing is you should be ready to share your best and available latest updated orbital information. Because what happens is, as Kannadi has already shown you, that if there are a lot of uncertainty available are associated with the object's position, what happens is sometimes people will do maneuver just to be safe rather than be sorry. So there are conservative measures which one needs to adopt to. It will simply ask for unnecessary service disruptions and fuel expenditure, which is not a desirable thing. So it is very important to have the best accurate knowledge of one's orbit to make any kind of informed decision for collision avoidance maneuvers. So this is not just applicable to you, or I said, but also for the other party. And if non-maneuverable status is known a priori, the party need not even contact you because they will take their decisions on their own and they need not waste their time in this kind of coordination. Then plus post-mission disposal is one of the most important aspects. So you should have ideally earmark enough fuel which we can use to deorbit your satellites at the end of orbit, so that it can cover, at least the perigee can be lowered sufficiently so that the object can re-enter the atmosphere within a span of 5 years or so. That is one thing. And if it is another option is to choose an orbit which is already compliant with this requirement. But at the same time, if you have any happen to have any leftover fuel, that can be used. But here, one of the mistakes which people do is they do not understand the meaning of the, don't go back, do not understand the meaning of the word residual of lifetime and post-mission lifetime and mission lifetime. So I put this kind of milestones. First to inject the satellite, then there will be an end of mission when your mission objectives are also met, or whatever number you have specified in the pro forma, like 5 years or something, you have reached the end of the mission. Then you will be taking some time to do a post-mission disposal. Please understand, post-mission disposal means there are certain actions you are doing on the satellite to deorbit or reorbit. It requires active intervention on part of the operator. It is not something which is happening passively because of atmospheric drag or any kind of other natural forces. So this part should be time taken for post-mission disposal, usually spans for a couple of weeks or months, unless you are doing something very elaborate like Cartosat 2 or Megatropics, which I have shown there. There the operation span for several months because they had interposed certain experiments in between. So that was one part. So this is one part where almost everyone responds in an incorrect manner. And then there is a residual orbital lifetime. After you're done with the operation PMD and the satellite is deactivated and passivated and decommissioned, then you have to this is the time to atmospheric reentry. This is your residual orbital lifetime. How much time it is, as it is still orbiting the Earth as debris object. So this part needs to be very clear. Remaining passivation things also can be mentioned as I put up here. Go back. So the next slide. Then again next. Yeah, you can just talk about or you want me to continue? So overall design reliability is something which we need to have for removing or reducing the chances of mission failure. That is true FMCA. And usually for heritage missions, this number can be easily derived based on the previous one. But try to at least give some number, something in percentage, which will be helpful. And then there will be a plan for post-mission disposal or to limit the failure modes which can lead to accidental explosion during operational phase. You can just click on the hyperlink. These are the typical responses which we expect. First of all, you should identify the accident-prone systems. This is like you may have propulsion systems or lithium-ion battery or something else. And mention that if something can have flight heritage or if there is any particular safety feature which you have incorporated, you can go back. The next one is for detailed post-mission disposal plan. So this is at the end of this are two types of just two particular responses which I have listed here. Here you try to tell what kind of deorbiting you are planning or reorbiting you are planning, and this is a typical response. Like you reduce the perigee below 500 kilometer or even lower, and this much fuel will be usually reserved for PMD. You can even mention the number of the exact quantity of the fuel which is reserved, and how many burns will be planned, and what kind of time frame within which you expect to complete these burns. Those can be mentioned. And most importantly, after doing all this post-mission disposal and active deorbiting, what will be the benefit you gain in terms of residual orbital lifetime? That can also be quantified here. And then there is a leftover fuel. This is another kind of response, and you can just somewhere try to mention that this will be compliant with the UN and IDC space debris mitigation guidelines, at least. That is the minimal requirement. And you can also mention, in most of the cases I have seen, the object re-enters within maybe span of 2 years or 3 years. You can tell that this is also compliant with the requirement of the DFSM. Okay, you can take over. And then I think this is the last slide probably. And if you have any failure mode analysis and system reliability figures for PND plan, here you have to mention the redundancy aspects and system reliability. Basically, what happens when the satellite is reaching the end of life, most of the systems tend to fail because they are designed for the particular span of time to survive in the space environment. So you should have adequate redundancy, which ensures that the actuators, sensors, and other objects, other critical systems are functional at the end of life so that the post-mission disposal can go through. So this is one thing, and this is particularly important when you are trying to extend your mission multiple times. And maximum delta V is one number which can actually be quoted here. You can assume the maximum ISP, so that is one thing. And next one is, these are some of the common mistakes which we come across, and so we have listed here. And this is first is the collision avoidance wise, as I've told you, there should be an answer should never be not applicable, write some minimal things. And also be sure that if you are availing services of external service provider, whether the service provider is actually taking the responsibility of collision avoidance decision making. Usually they will have a disclaimer telling that I am providing you the data, but the onus of collision avoidance decision lies with the operator. So just be careful of this, and better to clarify in the beginning itself who is doing the who is actually responsible for the collision avoidance decision making to avoid any kind of further queries. And there are always this problem which we come across, that people do not understand the difference between TLEs and ephemeridis. Ephemeridis is basically the entire span of the position and velocity table, whereas as TLE is just one done a lot of just an idea. There are lots of different dynamics, or if you must be having somebody who is involved in the flight dynamics team, get the proper data from them and accordingly and answer accordingly. Just do not use these terms very loosely. And then second thing is there will be one problem which is almost ubiquitous, that is trackability. Almost everybody talks about the maintenance of payload data and other things, so not the observational and tracking data or observational. Here, in this context, when we are writing it under the heading of tracking, it is not the observational data which is being collected by the payload. It is the tracking data, the measurement data which you are getting by radar tracking or some other tracking, or by your GNSS receiver, whatever the measurements are coming, position fixes which are being downlinked, or you are doing any kind of onboard orbit determination. All these are the data we are referring to, not the payload data. So you have to answer correctly here. And the another part is the most of the operators tend to overcommit, and they give unrealistic, almost to the extent it sounds like a science fiction, that kind of response when it comes to post-mission disposal. First of all, there at the end of the life, most of the actuators, sensors, everything gets turned off. And the spacecraft usually gets into something like a death tumbling, they call it. So it will be tumbling. There is no drag orientation maintenance, and there is no orientation control. So, and they're writing something like IL satellite will be put in the maximum drag orientation mode, and therefore with that assumption, with the maximum drag area exposed, the orbital lifetime will be so and so. This kind of response doesn't actually look good. You should not write like that. Just write the proper thing. Even if it is not compliant, it's probably okay. Rather than writing something which is unrealistic and then eliciting further queries and getting into almost seemingly infinite loop. That is not a good thing. And then there are a lot of this vagueness on mission life. I'm not going to dwell on this. This is one thing which we come across very frequently. And PMD requires active intervention. This point is already stressed upon some time back. And many of them just understand that the post-mission disposal, time to complete post-mission disposal is equal to the time for the spacecraft to re-enter the atmosphere. They are not the same thing. We are just asking you how long you need to be in contact with the satellite during the PMD. The reason we have put this is, you may recall during my previous presentation when we have put the Cartosat 2 being deorbited. Usually during PMD, it is required for the satellite operator to have a collision avoidance capability. So if the situation should arise that your satellite goes into the vicinity of a crewed mission, you should be able to do the maneuver and avoid any kind of collision. That is the reason this kind of time frame is being asked for. And failure to advance this thing, all the things are required, and then next one. I think that's all about it.
Can you open the other presentation, please? Now we will see the tools which can be used to do the analysis for these things. These tools which we are talking about are used during the design phase of the satellite, not during the, and these are needed not during the operational phase, and not, these are needed for your pro forma filling when you're applying for authorization from as an Indian registered space object. Next slide, please. So this will be the sequence, this will be the flow of my presentation now, and we will just touch upon the population models which we are having, and then we will go, we'll go through the debris assessment software and debris risk assessment and mitigation analysis software. DAS is by NASA and DRAMA is by ESA. Next slide, please. Right. So in the background, we'll just go to the space object population models. See here, there are different types of models which can be used. One is used for mission-specific analysis, like we call it as engineering models, and the others are for policy-making analysis. How, in the long term, how many objects are going to go up? So what are the type of authorization requirements that we have to keep to authorize any of the space objects or constellations for that matter? So these are required, these tools are required for planning your mission. Next slide. We'll go to the engineering models. So the basic two fundamental engineering models are RDEM, which is developed by NASA, and MASTER, which is developed by ESA. So the data sources for both are same. We expect that because both are the engineering models for space object population, they do not match, because when we say population models, those are not only for objects which are cataloged and tracked and cataloged, but these are for small objects which can destroy, like earlier Bulbul Madam has mentioned that a small object can cause catastrophic collision. If it is more than 10 centimeters, we definitely know that it will cause catastrophic collision. But if it is less than that, it can be a mission-ending collision, or it can compromise your mission objectives. So these are the models which are there. While modeling that, so keeping in mind that the large objects as well as the objects which cannot be tracked. So the approach taken by ESA and NASA are different. So there will be differences in the model outputs which you are going to get. We'll go to the next one. So these models are generally used for compliance with standards. DASA, because DAS, debris assessment software of NASA, is only for one country, so they have a country-wise standard, NASA standard 8719.14. So they have, it will just give an output key whether you are meeting the requirements of the country or not. Whereas ESA is a combination of, there are multiple states, so they can have multiple compliance standards based on their state. So it will give an little bit numeric values rather than just whether you have complied or not. And of course, with small, these applications are also used for satellite survivability, where you are trying to protect certain very critical surfaces from, like in human space mission, a window can be a very critical thing where if it impacts, it can have a lot of damage and may lose the pressure and those things. So for satellite survivability also, these engineering models are used. We are not talking about the satellite survivability part. We are going to talk about the compliance with standards part, which will be useful for your filling the pro forma. Go to the next slide. Yeah. So here, as you can see, this I have just simply shown a debris flux estimation from master and ORDEM. This is the typical output which will be there at an altitude of 747 kilometers and inclination of 98 degrees. The output will be something like this. Okay, how many objects may cross for a 1 meter square cross section per year? This will be the kind of so if your orbit is around 747 kilometers, there is a chance of more than 1 millimeter object like that. You understand the graph, right? This will be the typical output from the population models. We'll go to the next part where we see in detail about the population when we software tools. So debris assessment software, first we will try to see where we can access this software from. It is freely available in NASA software catalog, but you have to register there and you have to request for the software. Then they will ask you to write a software usage agreement where, like Bulbul Madam has already mentioned, whatever happens, you cannot say that because of this software I have done. It is your responsibility. You are using the software as a tool, but it is your responsibility. So those such things like IP and other things are also mentioned in the software usage agreement. You can, but it is mainly for protecting themselves. You cannot say that because of that software I have gotten into trouble. No, you cannot say that. And then download the software. It has a UI and it is fairly intuitive. It is very straightforward. We will see the UI as well, and we will try to go through each page as well. I have put up a software usage agreement just to understand. Next, go to. Yeah. So can you go to that source page? So after the registration is completed, once you need an account, you have to register in the software NASA software catalog, and then you have to request for the software. And then after some time, they will share an software usage agreement. After you sign the software usage agreement, they will take certain time based on how busy they are to approve that. Typically, it will be for 1 week or 10 to 15 days. We'll go to how to use the software. So generally, typically, these are the inputs which you need to give to debris assessment software for its usage. You have to give the orbital parameters in which you are going to fly. It will not ask for a specific ephemerides because you are not, even after going to the orbit, the ephemerides are not same after 7 days. So you have to recompute the ephemerides. So they'll ask for only for the mean orbital parameters and the initial and final mass and final area to mass ratio, and whether you have an option for PMD, like that. See, you have to give the general inputs, and the specific inputs are required when you are trying to see if there is any critical surface damage due to impact by small debris. For that, you have to give a specific inputs, like what is the aerial density and what is the type of material which you have used. They do not have all the materials and their properties. They have a library of some materials and properties from which you can select. Most of your survivability assessment, if you want to do such things also, you have to give the materials which you are going to use. And then other inputs you have to give, you may have to give as per the requirements. Then we will go to the UI and next slide, please. We'll see the UI. Generally, it will have three tabs. One is the mission editor and requirements assessment and science and engineering. Try to zoom into the missions tab, mission editor tab. Right click and try to zoom in. So here you can as you can see, there are payloads there, rocket bodies and any other mission related debris as per your launch. You have to add here as an example. I have shown you NVS-01 satellite, where the mission duration, which we have designed it for 15 years, and what is the operational perigee altitude and apogee altitude, and what is the inclination in which it is going to work, what is the RAN, argument of perigee, mean anomaly. If you're doing a PMD maneuver, please try to tick it. If you're not doing it immediately, if it is in a geo orbit, it will say that you're not meeting the requirements of NASA 8719.14. So these, if you are a little perplexed with the proforma before, it is very much detailed, you should go and see the FCC proforma. If you want to stay in space industry for long duration, you have to know these things. And these are the tools which you have to incorporate, not just before applying for the proforma. While designing the satellite itself, try to use these tools to understand what type of materials you are using, whether you have any critical surfaces where they can get damaged by small debris. And next we'll go to the, you can zoom out. No, you can, so that the second tab can be, so the requirements assessment. So since I have already told that DAS is for only one country, so the requirements are specified. These are the requirements. So in that, it will give you an output like this, where after running the analysis, it will say that whether the requirements have met or not, whether post-mission disposal is met or not. We are doing post-mission, like in the earlier thing, we are doing post-mission, as you can see in the top left corner, where disposal orbit is already given there in the mission editor itself. So based on that, it is saying that my post-mission disposal is that requirement I have met in this particular case. And next is the science and engineering tools, the third part, where you can actually calculate your drag area, your orbital lifetime, and how much it will be there. This is not an exact lifetime, it will not exactly match it, but you will have an idea of how long it will take. It might be like 10.5 years, means it will not be exactly 10.5 years, but it will be somewhere around 11 to 10 years. So there are certain tools which are available in that. You can use all these tools, which when at any point of time for your mission design. I think there is an orbit to orbit transfer, what will be the fuel requirement, all those things. I'm not talking about GMAT and other tools, because those are generally for designing the satellite, but these tools are exclusively for SSA. They are meant to be used from an SSA point of view. We'll go to the next slide. So we have covered where we can source how you can get the debris assessment software and how to use it. And we will go to the debris risk assessment and mitigation analysis software from ESA. So there is the ESA Space Debris User portal, where you have to register, and it is free of cost. Sorry, ma'am. Okay. It is free of cost only, and it is available publicly, but download requires for you to create an account, and you can just download the software. You don't have to, because when you are creating an account itself, he will tell that I am not responsible. Whatever happens to your mission is your responsibility. So you can download the software and use it as you want. And it has a UI for versions less than 4. Version 4 is not yet tested. It is version 3 now. Version 4 is in the beta phase. And it has very good programmatic interface as well. Unlike DAS, this has a very good programmatic interface. And you can use this. It is very much compatible with Python, and you can start using it in loop. You can go to the next slide. So how to use it? It has 5 main headings under which you can use, 5 main applications under which you can use. There is assessment for risk event statistics, where you are trying to assess what will be the risk assessment with large objects. And when there is a OSCAR, orbital spacecraft active removal. That means when you're trying to do any ADR or anything like that, what is the residual lifetime for that object, and what is the chances of you doing, what are the disposable options that you have, whether you can do certain maneuvers and the re-entry to happen. And you may have to give, in the italics, I have given the specific details you may have to have before going. In the first areas where you're trying to see the risk assessment, risk statistics, you have to give the accepted PC. So because like earlier we have told, Kandari sir has told ki it is 1 in 1,000 for that is what we generally recommend. But if any other country recommends any other thing, because ISA is made for not for one particular standard, for it can be for many other countries' compliance standards. So you can define your own accepted PC there. It can be 1 in 1,000, 1 in 10,000, or 1 in 1 lakh, or 1 in 100. So accordingly, you can. That input needs to be given. Everything in the italics at the bottom of the box is for specific inputs which you have to give to utilize the tool. And then there are disposal options, and what are the propulsion systems that you have based on which you can consider the disposal options in OSCAR. And MIDAS is where you see the damage assessment because of debris impact. This is useful for small debris where if you have any critical surfaces or anything like that, which may compromise your post-mission disposal or your mission objectives, then you can go for then you can go and use this tool for analysis. There you have to give the damage equations for the material which you are going to use. And of course, the shape and size of the material in which, what is the critical surface orientation and all those other details as well. Next is CROC. So this is used for cross-section of this is used for computation of complex body cross-sections where you have to give the reflectivity of the surfaces as well. If you want to know the accurate solar radiation pressure or the drag area for your object in a particular orientation, you can use this tool. And then there is a survival and risk analysis in which where you are seeing two aspects in this analysis. One is whether your spacecraft will actually survive the re-entry. That means whether it will get completely burnt out, or is there any chance of it surviving the re-entry and actually making the impact. The second part is where you are trying to see the risk. If it re-enters, where it will re-enter. What is the type of damage it may cause. And that analysis. We'll go to the next slide. So the UI will look something like this. Where you can choose which analysis you want to do, and it will give you certain options like basic settings and detailed population data, orbit uncertainties. This is for risk assessment statistics, risk event statistics. And like that, all the tools which I have mentioned can be used. You can click on that, yeah. Can click on. So this is for when you click that tool, you can zoom onto the this one. So you may have certain basic settings which you have to give. Then there will be you move to the right, and then there will be the sources which you want to consider. Whether you want to consider all the sources, you may know that certain paint flakes or something may not cause that much damage. So you may avoid using that population alone. So which sources you want to use, and if you have any particular population clouds that you have, like that Kuiper is going to put another 10,000 satellites, or Starlink is going to put another 10,000 satellites, you can add those population clouds here as well. And then you can use the meteorite sources also, which are limited here. And then you have to see the analysis mode where you are trying to, since this is impact flux which you are going to analyze, you have to say what is the surface orientation. You can define up to 10 surfaces here. If you want to do the complete analysis, you have to either procure ESA-based software for debris assessment when you want to keep the complete 3D model of your satellite and try to analyze. And I think this is the MIDAS part of it, and we'll go to the next click. Here is maybe. So this is again, like I said, each one will have its own specific data which it would need. If you are trying to use the tool, you have to know about this data, and you can then analyze the tool output, and you can accordingly refine your mission objectives and your satellite systems as well. I think we are running out of time, so OSCAR is also the same thing, and CROC and SARA also are the same. Similarly, it can go. You can go to the next slide. If you have any doubt during any of this pro forma filling or anything, you please contact InSpace and try to get clarification instead of not understanding it. Like I said, if you want to be in space for longer duration, earlier when maybe in the 1980s and 70s, this was not required, but now this is very much required. If you want to keep your presence in space for longer duration, you have to have this analysis, and you are to be familiar with these, all the terms, technical terms, and the tools which are available to do this analysis. So for drag area calculation, where you were trying to calculate this one particular, everybody was asking. So I have to put it in detail. So where you can, on the left side, I'm talking about the drama tool. On the right side, I'm talking about the DAS. In the drama tool, you have to use the CROC tool for cross-section assessment, and it will ask for a specific orientation. Can you zoom into that CROC tool? So where you will have still. Yeah, so you will have a main body. It can be a box plus 2 solar wings or something like that. You can define there, and you can define what is the surface, like shape of that main body of the each of the bodies. It can be, it is a preliminary basic shapes like a box, a triangle, and things like that, where you can give the. It is basically a projected area, right? Where with which you will calculate the drive. The output will be something like this based on the angle. If you give a randomly tumbling area, if you say that there it is randomly tumbling instead of a particular orientation, then you will be able to, then you will get then you will get an output like this, key, where you are be given average cross section, minimum cross sectional area, maximum cross section along the any of the look angles of the spacecraft. If your space object, if your satellite is not attitude controlled, you have to give them it as a randomly tumbling. You can zoom out and go to the other one. In DAS also it is something similar, where you have to use in the other utilities, in the science and engineering utilities, there are other utilities where there is calculate cross section area. There you have to can you come down a little bit? Where then it will, this window will pop up, where you have to select a shape, and then you have to select the orientation in the drop down menu. If you are not controlling the attitude of your satellite, try to give it as randomly tumbling, and then you have to give the different dimensions of the satellite according to in the units. Whichever units you are mentioning it, the cross sectional area will be given out in the same unit square. I think that concludes my presentation. If you have any questions regarding SSA, I think we have some 15 minutes for that. Thank you.
The floor is open for any questions for all the presentations that have happened so far. Should we take Slido's question in that case? Okay.
If I missed anything, Bulbul madam can.
GMAT will have this orbit propagator models and other things which will not be there in DAS.
Ma'am, another follow-up question.
So we are taking the conservative, we are doing both the analysis and trying to be conservative. So we would recommend the same.
Question. Is the performer for filling SSA details mandatory for all kind of space we need to do?
Yes, it is mandatory. Space, and that's the registration convention. Madhav can just elaborate on this.
Yeah, the answer is yes.
Can you elaborate a little on IS4OM?
Yeah. So in this, I think this forum is not the right forum to answer that. Any details which are available on the website as well. So you can contact us personally for more details.
Basically, IS4OM, basically this is ISRO system for safe and sustainable operations, space operations management. This was established in July 2022, and this concerts all efforts or all activities centers and also international bodies and other entities. So the ambit of activity spans from conjunction analysis,
Is there Indian government standard for debris mitigation planned for the future?
it is not, I wouldn't call it a standard, but there is a debris-free space mission intent which was unveiled in 2024 April during the very apt occasion of the plenary session of the annual meet of Interagency Space Debris Coordination Committee, which was held which was being hosted by ISRO as member. And this actually sets the guidelines or the requirements to be made by all space actors, whether they're NG and or by government, to ensure that none of the Indian of any kind of debris. And this objective is supposed to be made by 2030. So in ISRO, we have already spearheaded some of the activities and taken certain proactive steps in the design phase, especially for allocating fuel for post-mission disposal of LEO or satellites. This is one of the important things, and there are other activities as well which are in progress.
How does ISRO suggest prioritizing conjunctions during multiple simultaneous close approaches? I think what I understand, if there are multiple simultaneous close approaches, how the priority will be decided on what conjunction events to be done. That is my understanding of the question. How does ISRO take such? Sure.
How does it prioritize? Okay.
How does ISRO, shall I repeat?
Question is on the spot.
How does ISRO suggest prioritizing conjunctions during multiple simultaneous close approaches?
See, multiple simultaneous close approaches is a very, very rare thing. In case it happens, it has to be in such an optimal way to make the radial separation above the tolerance limit for all the things in the picture. It can't be like you cannot have two at the same time, but you have to optimize in such a way that the radial separation is greater than some value for both of them. The probability of collision has to go down at least 1 order or 2 orders less. That is what we do.
It's a tricky thing to do. I think that was the intention of the question. How is there any particular algorithm through which it is done? That is probably what the person was asking. Right now, it is kind of done through an iterative method because We have to do this analysis over and over again. The scenario slightly, and as
When, how should post filing, what are the processes? As a registration, so I am taking it as a space object registration. Can get post filling, it will be through the application page, and after that the contact details are provided where you can submit the periodic data, and you have to stay active till the you are responsible for the space object that is launched. For any further clarification, questions, but so not linked to the, if you allow, I'll take some more, or okay. Are there any templates performer do we need to submit the FMECA report for satellites?
You had a question?
Is there any can be used while we are submitting for the satellite?
It's available on InSpace website. That post authorization, they should submit. Audience here, please.
Yeah, hello. One of debit are also being explored. I understand that they are in very early stages. So first question, something that will mature in the next 4-5 years. And currently, where do we stand in terms of regulations or including this in the framework of space sustainability?
question is no. And second question is this kind of technologies dual use. They can be used to actually
We conclude. Yeah, you have a question.
My name is Devamurthy. My question is, if a company gets shut down, at the time the satellite is not going to be abandoned legally, means the lifespan it is still continuous in the orbit. Okay, so at the time the InSpace or our Indian government will take a charge for simultaneously monitoring that satellites. After that, company will get shut down.
Okay, can you repeat the question, please?
That means if the company gets shut down after sending the satellites, so the government will take the responsibilities for monitoring the satellites.
Who will take the charge of satellites for a company which is shut down?
The observation sensors designed to observe all the space objects are quite costly to begin with. So India has taken, like already mentioned, there is a project Netra that India has taken as a first step towards that. So we intend to track the objects, but as of now, the whole humanity, I don't know how many of you have attended any SMOPS conference which had ended last week, Friday. There it was mentioned by eminent scientists as well that whatever tracking we have as a whole for the whole of humanity are not sufficient for the space activities that are being taken up. So you intend to do that.
Okay. Thank you, sir.
Thank you. So our resource persons have spent their day sharing years of expertise. They have actually improved our awareness on the complex subject and ensured that we all are better equipped for a sustainable space operations henceforth. May I request Dr. P.K. Jain to present the mementos to our resource persons as a small token of our appreciation. May I request the resource persons to please come forward. Dr. Bulbul Mukherjee, Soumitra, Amitji, kindly. Madhav, ma'am, यही कर लेते हैं. Thank you. We will break for lunch now and requesting to get back by 2 p.m. for the second part of our workshop on ITU filings. Thank you. 25 minutes. Please. Thank you. Welcome back. Hope the lunch was good and you enjoyed the hospitality of ISRO. Are we awake? Yes. Okay. So, friends, picking up the right satellite frequencies for desired application is not just a technical step. It is like securing a lane on a very crowded highway. So, this part of workshop would focus on selection of frequencies for satellites and launch missions and accordingly making the ITU filings. Our first speaker of the afternoon is Shri Nitin Kumar Mutin, who is Secretary AMSAT India. He will talk about the need for IARU frequency coordination and amateur radio services on satellite that are going to use amateur radio frequencies. Over to you, sir.
Good afternoon, everyone. And thank you, InSpace, for inviting AMSAT India to this workshop. And as Madam mentioned just now, I'm going to talk about the need for satellite missions to go through the IARU frequency coordination. So before I begin, I just want to introduce all of you to this one. I just want to introduce all of you to AMSAT India. AMSAT India is a non-profit organization. Basically, it was formed in the year 2005. And our mission is to popularize amateur radio satellite activity in India. And we are based out of Bangalore. And it's a registered body under the Karnataka Societies Act. And we also help to advise the student and the startup community about using the amateur radio frequencies for their projects. So this is what AMSAT India and IARU is about. So basically, we support Indian amateur radio satellite missions. And also we bridge the teams with the IARU, which is the International Amateur Radio Union. Promotes mission with the International Amateur Radio Fraternity as well post the launch. And we have been having discussions with InSpace. We had very good discussions, and right now InSpace is positioning AMSAT India to these projects so that the project teams are in contact with us at a very early stage so that the mission is a success if they are planning to use the amateur radio frequencies. And in the below table, you can see some of the satellites missions where we have done the help with the frequency coordination with IARU. Again, as I mentioned, IARU is the International Amateur Radio Union. It's basically a subset of IARU, which is a satellite advisory panel. It's a group of volunteers who actually take up this work of doing the frequency coordination on behalf of IARU. And IARU is also kind of organization which is approved by ITU. And the member organizations of IARU are basically the national amateur radio societies in every country. Like, for example, in India, we have the Amateur Radio Society of India, which is a national organization, and they represent the interests of radio amateurs in India into IARU and subsequently into ITU. So AMSAT India is a recognized organization even by the Amateur Radio Society of India, and we work closely together to take care of the interests of the amateur radio operators in India and projects related to satellite services. So before I go into the IARU coordination, I think all of you must have heard about amateur radio or ham radio. It's a service again offered by various administrations worldwide. Like we have WPC in India, where individuals can take up the exams conducted by tests conducted by the WPC and then take up their amateur radio license and do a lot of experimentation on the air. So that is called as amateur service. And again, it is for the purpose of self-training, intercommunication, technical advancement in the field of communications. That's the main objective of this amateur service. And also, apart from that, we have also been actively involved in providing communications during natural disasters. And there are various examples that are there where we have been in the forefront providing communication during natural disasters, even including some of our amateur radio satellites. So again, what do amateurs do? We establish two-way communication with radio hams worldwide. We also operate at different bands, different frequencies. We have a licensed spectrum provided to us, for example, in India by WPC, where we can exclusively use those bands and the frequencies for amateur radio experimentation. We also work on different modes apart from terrestrial, satellite. We also do troposcatter. We do Earth, Moon, Earth, where we are able to bounce the signals off the moon and receive the signals back to Earth. So a lot of such experimentation, and also the fun part of it, we have contests and things like that. So I don't want to take much time on this. And then we are also very much involved in space. So the first amateur radio satellite, we call it as an Oscar, orbiting satellite carrying amateur radio. It was launched in the year 1961. And since then, there has been many of amateur radio satellites which are built by AMSAT organizations worldwide. And now, for the past couple of years, we have got the academia coming in, and they have also started building their own CubeSats with amateur radio payloads. And from an India point of view, I think all of you know about HAMSAT, which was launched in 2005. It was a gift from ISRO to the amateur radio fraternity. And it worked for almost about 12 years in orbit. And after that, AMSAT India also has been, we developed the first payload for the POEM platform. There was I remember working with InSpace, and they challenged us to build this payload within, I think, 40 days. We were able to build it in our home. And then we were able to fly it on the first POEM payload called as AISat. So significantly, there are a lot of satellites which are there, which can be used for amateur radio. And of course, as you all know, the capabilities that are there on the International Space Station, where we have the amateur radio station. We have also been talking to have the amateur radio capabilities on the Gaganyaan and the Bharatiya Antariksh Station as well. So let me quickly go about why IARU frequency coordination. Now, this is very important because many of the satellite projects, they are using the amateur frequencies in the VHF and the UHF for their telecommand and telemetry, and also some of the payload data. But the very important consideration from an IARU point of view is that any such projects using amateur radio frequency, it is not just because it's free of cost and there is no licensing fees and things like that. The project should offer an amateur service on their mission if they are going to use the amateur radio frequency. Amateur service is something which radio hams worldwide can utilize for the amateur service. And if that service is enabled by the project, then they can go and use the amateur frequencies on their mission. And that frequency is something that is being coordinated by the IARU. So that is very important, and it is very important because the coordination serves everyone's best interest. The other way is we don't want non-licensed amateurs or people like that to start using the amateur radio frequencies on their satellite missions. So again, key technical consideration is amateur radio service on the satellite and uplink, downlink bands. Yeah. Yeah, this I basically skipped because it's purely more into the rules and regulations. It's all there. But I want to actually spend more time on this particular thing on the amateur radio service on the satellite itself. So many a times what we see is many of the projects, they start with the design of their payload or their satellite, and they are not aware that this is a requirement that if they want to use amateur radio frequencies, they need to have amateur service. And they come back to us at the last moment, and it's very difficult to make changes in their design. If it is just the frequency, then it is fine. But if they have to incorporate a amateur service at that stage, it is very difficult. And we have had many of the academia and other startups who come to us at this stage. And it becomes very difficult to do the coordination with IARE. So that is a reason why we say that amateur radio service on the satellite is very important if you want to use any of the amateur radio bands. It is not only the VHF or UHF. We have seen some satellite missions where they even have used HF as part of their downlink and things like that. And again, uplink, downlink bands to choose between VHF and UHF. In the VHF, what we have a primary allocation from 145.800 megahertz to 145.999 megahertz. That's a primary allocation for radio amateurs. And what has happened is over a period of years, that small spectrum has become very crowded. So now what is happening, instead of having a VU configuration, most of the projects, they are preferring a UV, that is UHF uplink and VHF downlink, or UHF uplink, UHF downlink. So it is very important to choose what is the best configuration that is from a band point of view. Again, the power and modulation, again, it depends on the project. But if you are putting an amateur service on a satellite, the important thing to know is every amateur radio operator does not have the best kind of a ground station. They operate with very simple equipment like a handheld antenna, a handheld radio, which has got very low power output. So these kind of considerations need to be kept in mind when deciding about the power. And also about the modulation, like you cannot have excessive bandwidth. Normally for voice communication, we don't exceed 12 kilohertz bandwidth. And even for data rates, they don't approve anything beyond 16 kilohertz bandwidth. That's the standard definitions in IARU. And of course, the orbit and coverage, it depends on the project. Just to give an example, there was a recent project called as Green Cube satellite. It was a European mission from a university. And they approached IARU for frequency coordination. But this orbit was in the medium Earth orbit at about 6,000 kilometers. And they had a primary mission on the satellite. And what IARU challenged them was to develop a payload which can be useful for the radio hams, especially keeping into mind the higher orbit. And they came up with an idea of having a digipeater on that satellite. And once the primary mission was done, they turned on the amateur radio digipeater. And the satellite actually, it was end of life a couple of months back. But thousands of AM were able to communicate to the satellite using a keyboard-to-keyboard messaging. So these are the kind of things that can be considered in terms of orbit and coverage. And of course, interference analysis, that's part of the project itself. So again, the IARE coordination process, apply early, submit requests as possible in the design phase itself to allow for the frequency adjustments, provide technical details. The IARU satellite coordination board, they meet very frequently, I think once in a month, and they go through every request that comes in. There is going to be a back and forth between that team and the requester if there are any clarifications that they would require. And also, as I mentioned, it is team of volunteers. So we are all coming from different walks of life. I am IT professional. but we are like-minded people who come together similarly in IARU as well. So they try their best to clear those applications as soon as possible. I know as of now, I can see some people over here who have submitted applications for IARU and still waiting. Srinivas is here. So he's been following up with me on this project. So it does take some time, but definitely from AMSAT India, we can help to facilitate if there is any delays. And then finally, it comes to the frequency assignment. And then once that happens, that goes to in-space. And then through in-space, through your FMO I think in ISRO, it goes to ITU through WPC, who file it on behalf of in-space. So that's how it works. And there are a couple of slides. I think this is all going to be shared. And a lot of information is available on the internet as well. And I have been actively working with people in space whenever there are queries coming up on some of the projects. So this is all pretty. And here I want to call out some of the challenges in India. As I mentioned earlier, project teams, they do not consider amateur radio service in their missions at a very early stage of their project. And that complicates things. And also the increased number of CubeSat launches. Recently, there has been a comment about commercial organizations using amateur radio frequencies for their projects. So this is an observation from IARU. And I would definitely like to discuss this with InSpace and also pull in IARU into that discussion to understand what are their concerns. But they have been able to clear some of the frequencies for recently some of the projects, even though they were from commercial organizations. But they were actually initiated by an amateur radio club, which was formed within that organization. So it did not appear that it was commercial, but it was from a group of amateurs within that particular organization which initiated that project. So I think we need to have further, this was one of the recent queries that has been coming up. And spectrum congestion, as I mentioned, it is increasingly getting crowded over there. And sometimes we do receive queries from other administrations that a certain frequency that has been approved for a project in India, it is causing interference somewhere else. But there is no definite answer how to address this because it's so much congested, the UHF, especially the UHF band. And also coordination delays if there is a late submission. As I mentioned, it's a voluntary service. So some takes time. Again, is to engage as early as possible. I think it's the same what I mentioned. It's not much of change. And these are the satellite advisory panels. We have various regions. India falls into region 3. But we have Mr. Hans, who is in Netherlands. He's the one who is the main person looking after the coordination. And AMSAT India can actually help facilitate any kind of coordination request with the IRU team. So that's a very short introduction that I wanted to give to all of you about the need for having a IRU coordination for your projects. And we are also always available, and you can approach us if you want us to help you with the IRU coordination, or even engage us so that we can advise you on what kind of amateur payload that you can incorporate in your mission. And also think creatively of what you can do something different, which is innovative as well for the amateur radio fraternity.
So now we all know UHF, VHF, and HF amateur bands and the requirement of IRU coordination so as to avoid harmful interference. Thank you, Nitin. So next we dive into learning the various prerequisites of making ITU filing by Shri Vinay Paliwal. Vinay has served VSSC before joining InSpace and is currently working as Deputy Director, Spectrum Management, Monitoring and Supervision in PMA at InSpace. He is responsible for processing of advisory notes, enabling submission of ITU filing, and audit and monitoring of InSpace issued authorizations. Over to you, Vinay.
Good afternoon, everyone. Thank you, Sonali ma'am, for the introduction, and thank you, Nitinji, for covering some of the essential aspects that will make me go slightly faster in the initial stages. So, So as Nitinji covered, so RF spectrum can be used for various purposes. It can be for the using for any services like amateur satellite or for any commercial application or for safety of life services. It can be on ground applications or other things. So there are few questions that you may have that probably would have already been answered, but anyways, I'll come through. So who decides what frequency can be used for what applications? Are we free to use any frequency as we please while designing the satellite? Obviously, no. And definitely they have to select certain sort of frequencies or for each specific application. This gets further complicated when we talk about satellites, because for a satellite, what you call as an orbit spectrum or the orbital resource, which in case of GSO is the your orbit position as well as the frequencies. In case of NGSO, it is the frequency as well as the orbit parameters, which can be your the altitude at which you do the inclination and other, and specifically what position you will be transmitting or receiving. So in this key component other to be used is the coverage. So when you have a satellite, it is basically designed to cover a large area over Earth, which in case of GSO can be limited to a, based on your payload design, limited to a particular area covering the or covering half of the globe. And which in case of NGSO, if it is an SSPO especially, it will cover the globe inherently by design. Even for any other orbit, you will be covering a very large area. So the key difference between, though you are covering, you may not be providing services to all those areas which are covered. So the service region can be different from what is the coverage area. And service area is where you will need to take various permissions other than for what the intended application also. Just if you can click on the coverage and service area in the go back. Okay, no issue. Let it be. If you can see on the right side, you can see that there are certain zones covered. So you can see that we are in the orange geography, we are covering, we are designed to serve as a particular geometry. There are cases where you may cover the entire globe or the full circle or a particular portion of it. And there can be a case where a particular administration decides that they would not like to be part, that is, which is the case for a GSO satellite mostly. And you may decide to serve only a particular area. So all this given, there is a requirement that we need to regulate how we operate. This all comes so because the EM spectrum doesn't necessarily stop at the boundaries. The same service which you are applying, another the frame frequency can be used by any other operator for providing a different service or even for any other usage also. So we need to regulate. So who regulates this? This is the ITU or the international body, and in India, the national administrations. So ITU here is a specialized UN agency, which is formed, I think, in 1888 and then recognized by UN in 1947, which basically deals with the regulatory sector for the spectrum activities, which is mostly the radio communication sector that we are concerned with. It deals with all the ICT technologies. So the radio communication sector, standardization and development are the three sectors. We'll limit ourselves to the radio communication sector, which deals with the concerned activities. So now that we are here, the key question is who allocates this spectrum and what is allocation, what is assignment. So ITU basically allocates the spectrum to various services, and the national administration ultimately allocates for the regional application and assigns them to the prospective users. So this allotment process is a long drawn cycle which happens in every 4-year cycle through the WRCs. for which all the member nations and the agencies participate. The study cycles are done. And with those, a conclusion of those study cycles on a consensus basis, all that boils down to the radio regulations, where you can, this radio regulation also contain the frequency allocation and other matters. You can access the regulations. I have given the link below. The material will be shared with you. You can go and access them. So the regulations will contain what are the different services, what are the frequencies allocated to the particular services, how they will be recorded by ITU for the prospective users, the technical constraints that a user needs to follow for their operations, and how we will handle the interference and coordination procedures. So similar things are there in the national level also. On the left, you can see the ITU. There are 4 volumes. And on the right, the National Frequency Allocation Plan, recently released in 2025. I'm sure Amit sir will be detailing some aspects of it. Then the main key aspect in these regulation is the table of frequency allocations. So what you should keep in mind is how to interpret this frequency of allocation table. So the allocation, whatever is written in capital letters will be the primary service. Whatever is in the standard case will be the secondary service. Key thing is the primary service can claim protection and the secondary has to protect the primary service providers. I'll show through an example. One other thing is for the ease of administration, ITU has divided the globe or world into 3 regions. As already told by Nitinji, India comes in region 1 and the frequency allocation also, or region 3, and the frequency allocation also is accordingly. So here you can see the few of the services, whatever is written in capital will be, so let's say for 2300 to 2450, the fixed and mobile are the primary services. Amateur and radio location here are the secondary services. And another thing to see is in some cases it is harmonized. All 3 regions have similar allocations. And in some cases the allocation can be different. And there are various footnotes written below those, the allocations. So each footnote, I urge you to not just simply stop at selecting the frequencies, go through the footnotes that are given. The footnotes will provide you a key insight on how, whether what will be the approach for the filing or the entire process, and whether you should follow any technical constraints during your operation. Like for example, this 9.11 basically says that you will have to do an coordination filing. I will come to that in some time. So now when you are assuming you guys are a new operator, so how do you approach or how do you obtain an orbital resource for the satellite operation? So answer is by doing an ITU filing. ITU filing, what is ITU filing? It is nothing but an application to ITU. The key thing to note here is there is only one way to do it, that is through the recognized national administrations. And in this case for India, it is WPC. You can see the diagram on the left. You decide what satellite you want to do. You have to put up a filing. Filing goes to ITU and the due process. So there are 2 regulatory tracks. When you see, it can be a coordination or it can be through or not subject to coordination. We'll see what are the cases may be for this. And 2, management regime. Certain cases, ITU follows the planned approach where they have already dedicated the frequency orbital location service area for the usage by all the nations. And in certain cases, it goes somewhat in a first come, first serve basis, though not specifically specified, but the early applicants will enjoy priority over those who are coming later. So once you do, so how do you contemplate? You decide what is the service that I want to give. So there are, let's for example, you are an Earth observation satellite. So you will be imaging the Earth. So you'll fall under the Earth exploration satellite service. Now you can, for the operation of your satellite, you can have a different band for the space operations or the TTNC, or you may choose to do so in the same allocated band. But ideally for many of the cases, for redundancy or better reliability, at least for the LEOP phases, it is advisable to have 2 separate bands, but you are free to choose either the service band which you have selected or choose the especially allocated space operation for the service. Once you freeze down what is your frequency, then comes you go, what is the purpose of your thing? You go for the frequency selection. You refer the allocation of frequency table and see for your area specific requirements, what is the, any special constraints are there or not. In case you don't fit into this mold of the allocated bands, there is another option given. You can go to the non-compliant bands, but there is a risk associated to it. You will only be operating under non-protection, non-interference basis. which is the case. That what only means is if at all any interference is reported at known, you have to immediately cease the transmission and stop your operation. So once you decide on that what is the frequency band, what is the service that you want to give, there are bare minimum data that you need to provide for making a filing, which you should actually account in the design phase of the satellite. Which orbit your satellite will be operating, what will be the transmission antenna, how you will be transmitting, who all will be the receivers, which area. All these aspects will be covered in the filing. And this again just a summary of the regulatory track. As I was telling, it can be subject to coordination or not subject to coordination. That will depend on the what kind of frequencies that you have selected and for which service. So in case it is not subject to coordination, ITU process it through what is called as API. It is advanced public intimation. Then you notify it, then you ultimately bring into use. In case of it is subject to coordination, what you do is a CRC filing. So you can check the table and see for relevant markers such as subject to coordination under Article 9. Some details will be always be written in the footnote specified and accordingly choose for that. What is the expected timeline once you decide that you are doing? So what ITU suggests is the moment that priority sets in when you submit the filing to ITU. In both the cases, you get 7 years to bring in your satellite. This may change to 8 years in case of planned band. Let's not go into that. We'll limit ourselves to the 7 years. So whether it is so for any non-plan activity or which are, you get 7 years. You all start by either an API or a CRC request. In coordination requests, there are fixed timelines by which the ITU itself also identifies the affected administrations. They given time to provide their comments, and you will be given an opportunity to address them and coordinate accordingly. In case of API also, though there is no initial coordinate, affected parties are not identified, you will have to do the initial intimation, notification, and then bring in the satellite. So how do you do all of that? So there are certain mandatory ITU softwares. The ITU accepts it in a certain form only. So those, all these three, I think will be covered by ISRO expert, Mr. Himanshu in the next session. So you can feel free to ask. I hope many of you would have already downloaded the softwares also. So once all this is done, all the ITU publishes, how do you get to know which operator has made a filing? So what ITU does, it publish it in the bi-weekly circular, which is the International Frequency Information Circular. It is published in a bi-weekly basis, which will contain all the information about any new filing, the list of administrations which are affected, or any certain other informations with the new resolutions which have come in. The resource 35 here is specifically limited to the FSS NGSO constellation, these detail. How does a filing look? On the top, if you could see, I think I have taken Nisar. So you will have this information available. If you want to dig deep, you can go and select. Once you have your own account, you will be able to go further, see further details on it and go there. On the last column, what you see is how the BR IFIC is referred to. There will be a number of the number and the date on which it was released. You may, if you are referring to anyone else, you may simply give the IFIC number, the date of publication, and your filing number with which it can be referred. So the summary of what we have discussed so far, you decide what is your objective, what kind of service you want to provide. Accordingly, the track will be decided, either it is API, CRC. There is a third track, if I may say so. If in case you are a amateur satellite operator, you will have to also route it through IARU via the MSAT. You can take help of MSAT India, go there. Then provide all the necessary information in the requisite format that ITU recognizes, make the filing in that, submit it to ITU. ITU examines the adequacy of the input that is provided, then the filings are published in the IFIC. So if we are starting, the procedure to do all of that will be, the first step will be to apply to InSpace, where you just register on our online AIDP, InSpace digital platform, create an account, go to the authorization tab, submit the details of wherein you can submit the details for the applying for the ITU filing also standalone. In case you are not ready for the authorization as of yet, you are still in planning state, still you can go ahead and make an application for the ITU filing, as ITU also permits you for 7 years. Yellow link. This is how the application performa looks like. Somewhat details similar to what Nitinji had shown for IARU. The details are in somewhat similar. Only thing we are going into specific detail for your frequencies. Next slide, please. Next. Then there are few additional details that we'll be asking that are with respect to the interference analysis and your operational coexistence with the other operator. I'll come to that when we'll discuss on that. Can you go back arrow, ma'am? Once InSpace has done this evaluation, InSpace will be issuing you an advisory note. With this advisory note, it basically enables you to submit your filing through WPC to ITU. So you can go to approach WPC with the advisory note. WPC will also examine and ask you to submit the filing in the software. There are certain additional conditions which will be covered in the next lecture. And once the filing is submitted to ITU, there are certain further actions to be identified, which will be also be accounted in the authorization certificate. And then you can operate the filing accordingly. So what all will we link when we evaluate the authorization application for the satellite? So I have just covered a few cases. It is applicable for launch vehicle also. What is frequency of operation? If whether your satellite is for a communication service, remote sensing, amateur, or a tech demonstration, you will need to make an ITU filing for it. Even if it does nothing, it's only there for the space operation aspect. You will need to make an ITU filing. In case it is an amateur satellite, and coordination from IRU will also be required. And the frequency that you have declared at the time of processing of the advisory note and the filing, the operation should be limited to that filing only. The coordination strategy or the operational arrangement should be in place before you start operating the satellite. So the filing, just to cover you, it is not mandatory that the filing is Indian, and Indian satellite can operate under a filing of another administration also. So that is a freedom, but most probably likely case would be that it will be Indian satellite, Indian filing with that. So as of the coexistence here, as you can see, the applications are multiple. The satellite itself can be NGSO, GSO with multiple terrestrial activities also coming in. So the interference, any radio has a possibility of causing interference and receiving interference. So how do we do that? One of the aspect is frequency coordination. So the ITU filing, the process itself is somewhat designed to capture the coordination requirement. So wherein you inform, it can be either by way of API or CRC about what is your plan, what is your satellite network, you're planning a network with these parameters. You receive what other information about what others are planning, others also receive. You conduct technical discussion in case required, and you feel it requires further additional detail, you seek additional input, go there. And then you agree on a operational or parameters with which you can work upon. So this is what we are basically assessing the potential interference and determining whether it can be mitigated or it is acceptable to you. There are certain technical conditions which are by design designed in the ITU regulation itself. Then there are certain operational conditions which both the operators can co-decide mutually. So just a summary, the Article 21 basically deals about the satellite vis-a-vis the terrestrial services. How do you go? So that is done through the PFD limits. Then the GSO to NGSO operational consent will be discussed in Article 22 through EPFD. Then peer-to-peer will be coming in Appendix 5. So total summary, what all you need to do before you start submitting filing, you should obtain an advisory note from InSpace. This advisory note will be submitted to WPC. Then WPC will take you through on the process of the TICE account. Your user account will be generated. As a prerequisite, you should get familiar with various ITU softwares. This can happen in parallel. You need not wait for the advisory note to be issued by InSpace. Once you get the operator agency code, the filing is submitted. Thank you.
Thank you, Vinay. So now we are clear with the prerequisites for making a fresh ITU filing. Moving forward, let's understand the rules of land. Our next speaker from DOT would take us through the DOT guidelines and procedures for submission of satellite network filings to ITU by Indian entities. Shri Amit Gulati is an officer of Indian Radio Regulatory Services 1999 batch. Currently, he is the Senior Deputy Wireless Advisor in WPC wing of DOT and is looking after key satellite frequency policy issues, satellite frequency assignment, satellite frequency coordination, and notification. Amit sir, we welcome you.
Thank you, Sonali ma'am, for the introduction, and thank you, Vinay, for an excellent presentation. I think you covered everything. So I don't know what is left for me to be delivered right now. So we look at the guidelines for satellite network filings to the ITU and what procedure that we follow in getting a filing from you. So I'll be delving on many things. These are the takeaways, but before that, I think I'll supplement what Dr. Jain said. It's all about interference-free operations. So the whole mechanism of ITU is built to reduce interference. So as of now, ITU has reported more than 99.5% interference-free operation in satellite. That's a commendable feat. And that has all been done just because they have a procedure which is robust and which has been carrying on for several years. Now, the whole process is computerized. It's a software based. So you need not submit a paper filing anymore, which used to be there at one time. So I'll go along. So in takeaways, I'll just let you know about the mandatory requirements. What are the mandatory requirements before you actually think of submitting a filing to us? And what are the essential prerequisites? And then by the end of this presentation, we'll look at the procedures for processing the satellite network filings. As Vinayji said, there are certain bands which are not subject to a plan, subject to coordination. And then there are the plan bands. So what procedure do we follow? They're mostly similar. And then how do you do coordination with other satellite operators? So ITU does not recognize, unfortunately, any satellite operator. As also Vinayji said, they only recognize the national administration. This has happened this has happened for every country. So that 193 member states, and this is the responsibility of the member states to ensure that to submit a filing to ITU and also take into their ambit all the satellite operators. So, and then we look at the monitoring. How do we monitor the progress of coordination? And then the end of it, there is a mechanism that we have built for cancellations of the filing, because filing is the resource. So the filing may have been prompted by your making a request to us, but at the end of the day, the filing belongs to me as WPC wing. It does not belong to you. So as a nation, I have complete right over that filing. And then what is the right of use? What rights do you have? Once you have a filing, once you have a space object which is in use, you have certain rights. And then you can think of suspension of a filing. Say, for instance, you have a filing for a GSO space object, and then because GSO space object normally lasts for a period of 15 to 20 years. So what do you do after that? You need to bring another space object, because ITU says till you are using that resource which you actually filed, you have a right. If you stop using that resource till a certain time, okay, we allow you to bring about a replacement object. So what right do you have? You have the right of suspending a filing, right? You're not using that resource any longer. So how do you go about it? So we have a mechanism for suspension of the filings, and then we look at how do you relinquish the filing, right? So these are the key mandatory requirements. One is the advisory note. It starts off, your interaction with us would start off with an application to InSpace. And once they do their due diligence, they're going to submit an advisory note to us. Now, and then after that, you're going to submit a filing to us. And Mr. Himanshu in the next session will tell you how to create a filing. And there are softwares, ITU mandated software, which are mandatory for you. You create a software and then you submit that software to us, right? And how do you submit a software? I'm going to tell you what are the essential requirements after that. And then one of the mandatory requirements which are not mentioned here, and which Mr. Vinay also emphasized, is awareness about the radio regulations, awareness about the national frequency allocation plan. So it's like a lot of people have doubt, it is not like a chicken egg. So what comes first? Your filing comes first, or your space object, the hardware comes first? So it is always the filing which comes first. So your knowledge about the frequency allocation, what frequency resources you are going to use, that will come first. So you want to work on the filing first before you actually think of creating a hardware. Don't do the other way around. And then you need to know about the softwares and technical capabilities. There is a software called SpaceCap. There is a software called GIMS, and there's software called SpacePub, and there are many other softwares which you should be aware of if you are the one who actually working on the RF part. And then there is, when you submit a filing to us, for amateurs, it's free. So amateurs need not submit any bank guarantees or any processing fees to us. But apart from that, everyone else is supposed to pay a processing fees and submit a bank guarantee to us. Can you click that link here? Yeah. I'll go to the financial details. What are the financial obligations on your part? One is the ITU cost recovery fee. So ITU has created a huge infrastructure, whether you call it an IT infrastructure, or there are actually knowledgeable people out there evaluating your filings, which we submit to ITU. So to manage the costs, there is a ITU cost recovery fee. So once you submit a filing to us and then we submit a filing to ITU, they raise an invoice. And that invoice is payable by you within a period of 6 months from the date of raising that invoice. So it becomes obligatory on your part to pay that regulatory fee, right? And to cover up that, we ask a financial bank guarantee, right? So the financial bank guarantee is 2 times the value of the approximate ITU cost recovery fee. But the question is, how do you know what kind of cost recovery fee is going to be there? So once you want to create a filing on the SpaceCap, they give you an estimate what kind of ITU cost recovery fees will apply. So based on that, you can create a bank guarantee and you submit along with the application. And then on top of that, you pay a small amount of processing fees for the due diligence that we do at WPC Wing. So it's like for a satellite, for a structure where you have submitting a filing for less than 10 satellites, you will have a very small amount of processing fees. And then there's a processing fees applicable once you are creating a notification or a filing, which is called a CRC filing. So that is also there. Can you go back and click the link? Go back. Yeah, thanks. So these are the mandatory requirements, apart from the fact that your knowledge about radio regulations and national frequency allocation plans, those are also mandatory. We look at the essential prerequisites. Although ITU does not mandate, does not force you to create an operator profile, but we have, per se, we have said, okay, it's mandatory because it's like you can communicate to us very easily. By creating an operator profile, you can submit the filing online. You need not submit a filing attaching it in the email, because the email policy of the departments are quite strict. They don't accept MDB files and EXE files. So creating an operator profile makes it easier for you to communicate with us. So what you need to do is, initially, since you're not declared sort of an IT operator, so how do you go about it? So we don't force you to create an operator profile initially. Upload your filing someplace on the web and give us a link. But the moment we also get a request from you, we request IT to create an operator profile for you. And then subsequently, you communicate to us through the operator e-submission portal of ITU. And then the point is, how do you create an operator profile? Before creating an operator profile or even requesting us for one, you have to create a TIES account. So ITU has got a TIES, a login ID and a password. At one time, they used to also give an email to you, but email is not working anymore. The service is not working anymore. So they give a login ID and password. You can go to the ITU's website, which Mr. Vinayji said. So you can request for a TIES account. It does not come to me. It comes to the IR section, International Relations section in the DOT. If they have an issue, you can, they either come to us or you may contact them or us. We'll coordinate with them and they can issue, they can approve your request. The moment they approve a request for TIES account, automatically a TIES account is created for you. And then you can request us for an operator profile, giving us your login credentials, not the password though. Okay, as Vinayji said, you have, some frequency bands are not subject to coordination, where basically we call it collaboration. So what is that? So let us look at the procedure that we follow for processing of non-planned band filings. Certain frequency bands have been left by ITU, so they've made it less rigorous for you to be actually getting hold of a resource. So we look at the filing, and in midst of that, I'll be explaining a bit more. So this kind of filings are called API filings, so Advanced Publishing Information. So they're not called CRC filing, or they're not called Appendix 30 information filings. They're called Advanced Publication Information. So based on your advisory note that you got from InSpace, you submit a filing to us, but make sure that the parameters that you use are exactly the same. They're not varying from the parameters approved by InSpace. And then you submit a filing to us along with all the prerequisites, the processing fees. Financial bank guarantee you can submit a bit later before we submit the filing to ITU. For us to be processing the case, your processing fees has to be submitted to us. So we will guide you how to do that. And then we take some time to scrutinize the filing as per the regulations of the ITU and the National Frequency Allocation Plan. Don't forget to read the footnotes that come along with the RR and also the National Frequency Allocation Plan. That will guide you on special provisions for various frequency bands. And then as a part of the scrutiny process, we ensure that your filing is not submitted directly to us, directly to the ITU. Before that, it is like obligatory on my part to take on board all the national operators who have interest in that frequency bands. So we do a sort of a national coordination. We have a mandated timeline of 30 days for the national coordination to complete, so that the international coordination is not done at that stage. You get your homework first and then submit it to ITU. And after that, I will submit it to ITU. Then ITU every fortnightly comes along with a publication called BRIFIC, BRIFIC. So it's called International Frequency Information Circular. So every fortnight, they will publish the parameters submitted by not only by us, also by all the administrations. So you need to look out for that. And getting access, I'm not sure whether it's for everyone or maybe the TIES account holder. So that will also give you access to the briefing. So after the publication, 4 months, you have 4 months. As an administration, we have 4 months to submit the comments to ITU, whether you agree to the assessment of ITU or not. Maybe you have something additional to comment on that. But you need to submit your comments to us within 3 months, so that you're giving us a time of 1 month. And then after that, there would be a sequence of events where you need to coordinate with the operators of other countries. And you cannot do that on your own. So you need to involve us, because for the first time. So you need to submit a letter to the national administration of other countries who have been identified by the BRIFIC. So you submit an application to us stating the obvious, and then we submit it to the administration of other country. Then you can coordinate amongst operators, so you operator or maybe some other countries' operators. This is a procedure for processing of the non-planned band filings, which are not subject to coordination. Say, for instance, somebody is interested in creating a space object to explore Earth. So there are certain bands which are not subject to coordination, like the 8 gigahertz band. So those are not subject to coordination, very light touch, or rather it's called collaboration. So I'd say like ITU leaves it to the operators to sort out things among themselves. It's like if your space object is trying to emit a frequency in 8 gigahertz band, and it is like an NGSO and going above such certain other administration's country. So you can coordinate among that operator. Okay, say fine. When my space object is above your country, I'll turn off my emissions. I will not work on that. So these sort of coordination, maybe turning it off or, tinkering around with your power and ERP, all things like that. So, and then there is a procedure for frequency band which are subject to coordination. So you have there you call CRC, exactly the same procedure, but it's a bit tedious because, it's more of a coordination. So you may have to work harder because certain bands are subject to coordination. And as Vinayji said, how do you know about which band is subject to coordination, which is fit for an API? So you need to have a knowledge of the radio regulations, look at the frequency band, and look at the associated footnotes, then you'll come to know. And the CRC bands will be subject to a much more larger cost recovery fee. So take that into consideration before you design your network. So simply blindly choosing a frequency band based on your needs will increase your cost. So please take that into consideration. Exactly the same procedure. And then at the end of it, you have to submit a notification and a bringing into use filing. So once you do a notification and the BIU, we call it, ITU enters your filing into their MIFR, Master International Frequency Register. So that gives you an international right, a recognition that you had successfully done coordination and you can use resource. So you can use that resource as long as you are using it, as long as that resource is being used. So you have that right. And that is a must. That is the reason why you have more than 99% interference-free operations throughout the world. And then we have procedures for plan band. And plan band are certain frequency bands for fixed satellite service and broadcasting satellite service. And we have a couple of allotments. So it's like, and it's only for GSOs. So we have 3 allotments in one allotment in FSS and 2 in BSS. So it's like we call it a plan band. So because there are a set of parameters which are already there. So anyone from the administrations who have an allotment according to a certain plan, they can straight away put a space object and start using that based on those frequency parameters, exactly frequency parameters. The moment you deviate, you need to do the same coordination process as was done in the CRC. Here you are given an 8 years regulated time period from the date that filing is submitted to the ITU. So the date of receivability of your filing decides your priority or decides your seniority, because ITU follows a first come, first serve process. So if I make a filing today and someone who makes a filing tomorrow, I become senior to him. So he has to coordinate with me. So it's all a principle of natural justice. So, and one thing I'll reiterate again, every filing has to be submitted through us to the national administration, because I represent the national administration. Though you can directly contact an operator informing us, keeping us in loop. And you should seek the support of WBC Wing in case a certain operator is not replying to you, as we have been doing. So if you think that your letters are being unheard of, not being replied to, you can take us into confidence and we will do the test. And then once you have an agreement with an operator, that agreement holds no value till it is ratified by the national administration and submitted to ITU. So any coordination agreements that you do with other operators has to be ratified and then submitted to ITU. We also monitor the progress of coordination. We have an 8 years timeline. The 8th year is only for the plan band. So we keep on we keep on checking what progress have we made in coordination. So as far as the API is concerned, it's a very light touch. So not much is to be done on that. But this will be applicable only for the CRC, where the bands are subject to coordination as per section 2 of Article 9, and the plan band. Here comes the due diligence. It was also covered by Vinayji. You have to, for CRC and plan band, you have to submit some mandatory information as per ITU resolution 49. So you can get more details on resolution 49 from the ITU website. This is the 3rd volume of the RR. So you can see here you have to submit the agreements that you had with the satellite manufacturer as well as the launch service provider. They want to make sure that you have really doing something on making a satellite and trying to launch it, what kind of timelines you have. Okay, coming down to the last segment is about cancellation, right to use, suspension, and relinquishment. What are those? I'll come to that in a little while. Once is the cancellation of filing, right? First cancellation happens at the top level, at the ITU level. So this automatic cancellation happens if you do not follow the regulatory process of ITU. So if you do not bring into use a resource, you have a file, right? You do the coordination part, but at the end of 7 years, you fail to bring into use a satellite. It would be a paper resource. So it's of no use to ITU, they will cancel the filing. Right? Another way they will cancel the filing is like you don't pay the cost recovery fee, or somehow you don't follow other procedures of the ITU. So automatic cancellation happen at the top level. And then early cancellation may happen at my level. So I may cancel a cancellation of filing if coordination process indicates that completion within regulatory period is difficult to achieve. So if I see that you're not serious enough in coordinating for a resource, think of canceling a resource rather than putting the filing with ITU. And then third level happens at your end. It's a voluntary cancellation. So you can request for a cancellation anytime. And then comes the right to use. Once you have a resource which is recognized in the ITU's Master International Frequency Register, so it gives you certain rights. There are many filings which are like decades old, like 30 years old, 40 years old. How is that possible? With space objects, they don't last that long. So they have a certain right to use. The moment, till the time they are using that resource by putting up a space object and the parameters as in that MIFR, you have the right to use. Here, the duration of rights. So you have a right of around 20 years or till the time you are using that resource. So you have a satellite which is not working anymore. So you have a LEO satellite has a lifetime of 7 years. And then you don't have the money to put in the space object again, so you lose the right. So you don't have any right any longer. And then there is a, as WBC Wing and InSpace, where you have to come out with what kind of process we'll have, what kind of fees we will have. So you can always renew. You don't have a perpetual right to the resource. So even if you build the space object, you use that resource, but you don't have the right to it till you go through the renewable process. But that's a long way to go, 20 years. So we'll have enough time to actually go through the right to use process. And then comes the modification in the right to use. So there could be what could be the ground of reduction. So it's like you don't pay the renewal fees. So when the time comes after 20 years, you are given an option of getting hold of the resource and putting up a fresh space object. You don't do that. So, we could revoke your right to use. But for any matter, we follow the due process of natural justice. We don't make a decision. Here comes the suspension of filings. So what exactly is the need for a suspension of filing? I briefly touched about it. Like you have a right to a resource, but somehow lose the space object, or perhaps the space object suddenly dies. So would you want to complete the whole process for 7 years? Absolutely not. So you don't like to go through the whole coordination process. So you have option of suspending your filing, suspending the right of use. So ITU normally gives a period of 3 years, right? So you can suspend, or rather you give me a request. I forward the request to ITU. The request or suspension goes to ITU and they give you a period of 3 years. Within a period of 3 years, you have to submit me whether you are in a position to submit a new fresh space object within the period of 3 years. The other mechanism also which you can find it out from the
Article 11 of the regulations. So InSpace also periodically assesses the applicant's readiness to bring it back into use. Once you've suspended it, it becomes mandatory that within a period of 3 years, you have to bring back into use the space frequency assignments. Otherwise, ITU would cancel it, right? And if in case you have suspended it and you're no longer interested, so there is a mechanism called opportunity announcement where ISRO would come out with an announcement of opportunity where they would give that filing resource to someone who is actually thinks that they are in a position to bring into use within the period of 3 years. And there is a mechanism to relinquish a filing. So for that, you need to submit an application to InSpace. And then InSpace again, comes up with the same announcement of opportunity process. So that is a two-step process, having your technical capabilities and a financial capability. So anyone who is interested in the announcement of opportunity can straight away skip the whole 7-year process and directly jump onto a filing and get hold of that resource. And then they submit the recommendations to us and we communicate to the ITU. Well, thank you.
Thank you, Amit ji, to teach our audience to navigate the corridors of DOT and make ITU filing. So we will have a quick tea break now, and we would reassemble at 3:40? 3:30. So, and we will reassemble at 3:30 for the very useful tutorial on making an ITU filing. Please have your tea. Thank you. Shri Himanshu Kumar would take us through sample preparation of ITU filing covering remote sensing, amateur and communication constellations. Himanshu is Deputy Director of Frequency Management in SCNPO, ISRO headquarters, contributing in the areas of coordination of orbit frequency resources for ISRO's communication, navigation, and remote sensing and science mission satellites. Stage is yours, Himanshu.
Thank you. Good afternoon to all. And thank you, Sonali ma'am, for introduction. And hopefully this is the last session. And I believe I've been told people are waiting for this one. So basically, what I have planned for today's presentation and hands-on is that for 4-5 minutes already there is a recap what has been told by the Vinay and Amit sir, and then later on to what are the preparation, what you have to do for the filing, what all the some screenshots I have prepared, and then I will go towards the ITU website from where not software where you can offline you can make your all your filings how you can do. So this time what I have planned right now for the simple API filing that I will go through that, and there how you are going to, which are common mistakes people generally makes, and ITU's webs, that software, Spacecom, whatever, Space Cap, where we are going to do this one. They give that where is the fatal errors are there, where warnings are there. So many things are there. So software will automatically tell that, give us those idea to us. At the same time, at the last, I will take you to the ITU website, where IFIC, you might have heard the IFIC, and how to interpret those filings, and where you can do your what you call, you can object, and you can see how many people have had the filing, and which frequency you can have, and how you can plan for your frequency and all those things. So starting from this one, hope I am clear to my plan of action. Shall I proceed? Yes. So can we go to next slide? So anyhow, this is the common process being followed by everywhere. So this is only of repetitive of nature, whatever Binay is produced, Binay had shown to you, and Amit sir has done. Here, if you see, the only part which you find at the right side corner of that one, which is not being told by anybody, which is very important when you are making the ITU filing. Rest all part from the left side towards to go to the except this part, you have seen all these things being told by the earlier speakers. So this is the part which is very important when you are making a filing. So these are the essential parameters which you have to find out before you start the filing. So you need to have the knowledge of what is the orbital parameters, what all the your frequency bands, what all your link calculations, all those things, and earth station details. These things you need to first capture in your beforehand before you go for the filing. So coming to this point, so generally these are being technical parameters, what you call consultation with the project, because regulatory people are always different from the project people. So I don't know the structure. Generally everywhere the structure is regulatory is totally different than project people or the working people. What I am seeing here, 2-3 people which I know personally, they have the more than experience of more than 20-30 years in the frequency management. One of them, Kevin, is here, and another is Rajat Ali sir is there. So, concerned to me, I am having the very less experience compared to them. So coming to here, then you have to, what you have to do after doing this one, you have to go for the submission through ITU. As Amit sir was telling, for any filing, it is the administrator of this ITU recognize only the administrator. So administrator is the only responsible for the any filing done by any country, any sovereign nation. It doesn't recognize any organization, any satellite operator, anybody. So in turn, those satellite operator or organization is being recognized by the administrator. So if you heard of Intelsat, Inmarsat, anybody, those are being recognized by the respective administrator in the country, like if USA, France, Netherlands, like this thing. There are so many administrators through which these filings are being made. So after doing this one, so then ITU validate those things. Validate based on when you are going through the software initially when they are checking for your filings, they only do initial checks. They are not going for the before going to ITU filing. When you are putting on software, they are only checking your frequency allocation of travel, PDF limit, and affected network information based on the previous database what it is having. So only based on this, they accept your if it is in line and with the what you called filing. The word I can use is the way it has to be filled in the form. If it is in proper format and checking this one, the ITU publish those things. And at the same time, when ITU publish, it is doesn't give you the every right that it is your slot, your frequency, your everything. It is only a ITU provide you the coordination mechanism and regulatory mechanism to protect you. It doesn't give you any other right as per my information. So after this one, ITU publishes, then you have to do all the anybody after publications, all the affected party by the identified by ITU or by somebody administrator who is seeing that their network is affected. They request ITU that the particular network published in your this effect is going to affect my networks. So you need to ask for the coordination with us. And then after this all agreements had been made, then finally when you launch your satellite and you plan to launch your satellite, when you launch the satellite, then this resolution 49 that is called due diligence, which is being filed, and then your network is again published in the ITU. There are notification stage and all those things. Then finally it is published in MIFR and it is registered in your satellite network. Is registered in the MIFR that this satellite network is operational. So this is all the process it is going through. So can we go to next slide? So coming to the process, so my total presentation today or whatever my discussion will be only remains to this three of this one. I am not going beyond this, all those things. Can we go to next? So coming to this one already been, I'm going to repeat this first half, left side of this one, because all the ITU regulations are being dealt with all these 4 volumes, which Vinay had told you. In that first one is your article, which regulates all the rules, regulation, how all the parties, means all the network operators and network filings has to be dealt. It is either the filing stage, coordination stage, and all those things been dealt in the volume 1, that is called article. Second is the appendix, like you might have heard right now, plant band and all those things. Those are being dealt in the appendix. Then third one is all the resolution and recommendations. That is the different study groups publish their recommendation, which is adopted by the adopted by WRC and being added by Bureau of Radio Communications. Those are in volume 3. And fourth one is the recommendation incorporated by reference. Some reference has been there based on that. So these 4 volumes is always being updated every 4 years through the WRC, the World Radio Congress. It has been updated every 4 years, and it is always a, what you call it is a living type of documents, which is keep on updating. If something obsolete that has been deleted, some new things are coming that been updated. Like you might have heard article 21 and 22. 22 is recent add of in 2002. What I remember, WRC 2002, it has been added. So it is a continuous process based on the technology evaluations is going on, based on this being all been updated. The second part, what you see is the IT software. which we will be dealing how to do this one. These softwares are also being updated based on every WRC passed some resolutions, certain new limitations, certain new regulations had been done. So these had been keep on updating all the software based on the adopted by the WRC. So again after WRC, all regulation had been adopted and it has been changed. There are certain satellite network operators or the administrator feels that certain of the features of this one is not filling the requirement, or there may be some changes are required to there's some bugs are coming, some errors are coming. So these all softwares are being keep on updating on this one. So if you see, there are versions 10 and there are certain things. If you 10.03, these are keep on updating based on the major changes if it is being made in the time. So, and here if you see, there are so many softwares are there. So presently today we will be dealing only with the space cap and other softwares we are not going to deal today. And hopefully times are also not there. But if you see, space cap is the where you can capture your all your network which you are going to publish, we are going to submit to the ITU. Whereas the spacecom is there when you are making certain comments to the ITU based on some other publication where you found that it is going to affect your network. So it is for the spacecom, whereas other BRCs and all these things are there for your query from database. You can query, you can find out what all the networks are there, which networks, what type of filings, where are restrictions are there, and which country has been notified, and all those things you will be getting all these BRSIS software. Third, last miss in this one is the GIMP software. It is the software where you capture your service area, antenna diagrams, if it is not in the list, predefined list. So you can capture in the GIMP software where you can define your service area, particular service area. And there are GIMP software which regulates the PDF, EPFD limit, your ERP limits, all those things. You can check it on the GIF software. And other parts are AP30B reports and all those things. So that is on other part. So generally when we are filing, these are the one software, SpaceCap, GIPS and GIPS. These three are very important software where we need to focus more. So just to repeat whatever Vinay has told, so if you see, there are ITU orbital orbit frequency rights are first come first served basis. It is just to you need to operate. Once you are not there within the time limit, it has to be, it will be seized or suspend. As Amit sir had told, there are some time limit within 3 years. You need to bring out your replace your satellite network. Then as Binay and Amit sir told, when you are making an ITU filing, once it is being accepted by ITU, once it is not accepted by ITU, it has been submitted to ITU, then within the 7 years, you need to bring your satellite. Then for to register a satellite in the orbit in MIFR, you need to continuously operate for 90 days at the particular locations or particular orbital. Then in case of failure, if you have a failure chance and all those things, suspensions, there are certain regulations, those are being noted here. Then coming to the other part of coordination, whatever being told, so generally this is dealt with when you are going for the communication satellites. So there in communication satellites, the steps are same process is same. That if you see in the right side, there is process are the same. process are the same. Here, what I am wanted to tell you that for satellite to coexist, ITU identify affected networks. Once you submit your CRC and any API filing, so they identify generally for the CRC API when it is not the satellite network not for the coordinations. The rules are not so stringent, but where in the CRC where it is for coordination, rules are very stringent. So there you need to coordinate. So ITU identify based on different criteria which satellite need to be coordinated. Generally, one is the arc basis. The arc for general which need to be coordinated, compulsory coordinated for C band is around 7 degree, Ku band is 6 degree, and Ka band is 8 degree. So if you are within the plus minus 8 degree of your network, you need to have the coordination with the satellite network operator of those who are senior to you. And other is your based on the delta T by T, means interference based on the your or whatever filing parameters of your links. If it is affecting to other network, that is called delta T by T. That is the coordination. It should not exceed more than 6%. That is 12.2 dB. Your CRI should less than 12.2 dB. So then coordination is also that coordinations between different users being done based on the service area and the type of ground station you are going to use, and all those things are there. So I'm not going to dwell more on this one. So coming to the filing parameters, how to define all these filing parameters to understand any ITU filing. If you start, that is first one is your orbital slot or orbital orbital position, orbital parameters. So ITU, if you find first page, if you find, you will always find that orbital parameter. This is just a capture from the API filings. If you see, there are you have to find out the inclinations, then your apogee height, perigee height, and the time period of your durations. And at the same time, if you are filing of yours, if it is a NGSO satellite, then you have to give your, it is a sun synchronous or non-sun synchronous, more than 85 degree of inclination. If you go, it called a sun synchronous type of systems. If less, it is non-sun synchronous. So if it's sun synchronous, then you have to give the local time when it is crossing. That local time reference should come from either it is a ascending node or descending node. So if you see this orbit of this one, to understand what is what, so apogee, perigee, these all hopefully everybody is knowing, so I need not to explain. So better what I make you to understand that is the inclination you need to know. Inclination is just to your orbital plane with respect to the equatorial plane. What is the angle? That is the inclination which is required for you to file here. Then apogee, perigee, height, and the time period, what it is making time for one revolution. So this is the one of the orbital parameters. Then second part, if you go, there are you have to go give it to your service area. The service area here is the where your the ITU. If you see, ITU generally identify your satellite network based on your frequency and the orbital parameters. So this service area, generally when we call it, it is the where your RF signals are either being beamed in or beamed out, means from where you are uplinking your signals or you are downlinking your RF signals. So you need to give that which all service area you need to you are going to have in your satellite network. So it has to be decided pre-handed before you. The second part of this one is your type of service which you are intended to have with your satellite network. If you see this all API concern, the generally we are dealing with the space stations. There are right now whatever I have captured with the space station, it is for the ground station also. So this receive and transmit the convention if you use, it depends on the which type of filing. If you are doing the space stations, so anything transmitted from ground, it is accepted, treated as receive, and what is it is transmitting towards Earth, it is as a transmitter. So it is with respect to the reference where you are taking. Whereas ground station, it is become just ulta. So that convention you need to always understand that I will bring it to other slides where it comes. So then it is a type of space station, what type of service you are going to provide. So I will take you to the other place where you can find where all the services are there. And these are the some of the what you call nomenclature has given different type of service, and there is nature of service means when ITU started, it was the two peers when it is communicating, the way how it will communicate, it is a personal one-to-one communication, it is a public broadcast, or it is a very specific few people are coordinating. So based on that, this type of nature of service being decided. And third part is the polarization. What type of polarization you are going to have for your receive and transmit frequency. And if because I have captured for receive, so you will find the what is the noise temperature of your receiver on board. And other part you will find if the service is like of inter-satellite, then you need to give up the ERP of your transmitting source for this one. All these details are required when ITU, after submitting your application, ITU do the link budget analysis, everything. That time, all these datas are very important for ITU to make the link budget and affected network, all those details, it will make from there. So can you press this one just? And this is this preface is available in ITU website. I will take you to there from where it is available. So can you go to 145 page number directly? So here on the preface, if you see, there are the countries name. Just hold on. There are the country name or the administrator from which you are going to make a filing. So these are the list of the countries for everything. They have noted all the 193 countries. Can you come down to 150 hopefully? Yes. So this is the country where you can have the service. So this service, and it is shows the code regions and the administration which on which this service area is belonging. Can you come down to 154, hopefully 54 or 58? Just hold on here. Just to tell you, once your service area is like a region 1 or region 2, region 3, so you can use the code like XR1, XR2, or whole globes, XAX, like different type of codes are there, so that you can use if you are wanted to put your whole globe as your service area from anywhere. You can uplink and downlink your systems. Come down. Yeah, here. So this is the type of class of stations. So this preface, if you go through, you will find different type of service. ITU recognize around 43 type of service in different terrestrial service or radio communication service. There are 42 or 43 type of service being recognized by the ITU in different. So they have, for the space service, they have recognized around 12 or 22 type of service. So you can check from this type of service, which type of service you are going to have. Similar service, if you are checking, the similar allocation has to be there in the table of allocation. So it has to be mapped with the table of allocations. If you are taking a class of station here as a, if you take as a ED space telecommand if you take as a, this one space telecommand space stations, so you need to check either in the particular space operations, whatever is allocated to space allocation, space service allocations, or a particular type like ESS. In that you can use this one, but you cannot, like if you go to EC, like space station fixed satellite service. So if you are taking this as one, so you need to take in allocation table what have been allocated for particular this type of space stations. Any question as of now? Sir, like space station fixed satellite service. So if you go to table of allocations, article 5 of the volume 1, there are frequency being allocated for different type of service. If you check in C band, the 59252 to 6425, it is being allocated for the fixed satellite service. So if you choose as your space station is EC, so you have to map the same frequency in your frequency allocation. If you are taking as a EC here and you are going for the certain which is not being allocated in your frequency table, you cannot use that one. That is the meaning. It will not accept that software. Software will give you the error. So come down. Similarly, if you have selected the space station like EC, so similarly ground station also. If you find the ground station, it will start with T, whereas satellite service space station start with E. So these are the means you can match with the type of space station with the ground station. Come down a little bit. Yeah, 1 minute. So this is a nature of service. This has been legacy. And generally, when we are going to use like space station open for official correspondence exclusive, like public correspondence, when you are having the broadcast service, VSAT type of service, it is the anybody can use. So you can use for the station class CP, wherever you are going for like a TTC, a command type of things, you can use like station exclusive for operation traffic service or CO type exclusive correspondence. So it depends on type of nature of the service, what type of communication you are going to perform with your space station or the ground stations. We can come out and go to the slides. So next slide. So another, this slide, what we capture it here is the, what we wanted to capture is the designation of emissions. Your space station, how, what type, all type of emission it can have. So it again depends on what type of system you are making, how your ground station is going to communicate with the space station and how space station is going to transmit. So if you see, there are certain format in which you can provide your emission designator, and in that also there are frequency, which all frequency you are going to use and where, and these are just capture of type of beams. If you see here, it is a receiving beam, it is transmitting beam. This software captures everything. It is give you the visual impression also, how it is coming, what is there. So all those things you will get here. Can you click here just? what I wanted to bring you that there are how you can decide the emission designators. So this is appendix. These are all available on ITU website. So the first four letters, if you see, it is the frequency bandwidth which you are going to use. If you come down little bit down, little bit down, example, yes. If you see here, the first four letter in your emission designator is the how you can define what is your frequency band of, not frequency band, it is the bandwidth of your service. Not the full band, the type of carriers, carrier will, what will be this emission. If you check, see megahertz being 1M25 means 1.25 megahertz. If these are the way you have to designate in your, when you are making a designation of your emissions. So this is for first four letter is the your frequency band of operations. Can you come down? Then
Can I just add what you said?
Yeah.
Okay. While you're making a filing, make sure that your frequency range is not too restrictive and your emissions are not too restrictive. Because once you start coordinating 5 or 6 years down the line, if you see that you've all at the initial stage you selected a frequency which was quite narrow, you cannot increase that. Start the other way around. Have a very broad frequency parameters and emissions. And suddenly, once you start to coordinate with other operators, you try to be restrictive, not the other way around. So make sure that it is you stay within the envelope. So if you started from 4 megahertz, you can come down to 3, 2, 1. But if you started with 1, you cannot come down to 2. IT will not allow that.
Just to add to Amit sir, what Amit sir wanted to say that when you are making a filing, the coordination process, if it starts, it is always a shrinking side because nobody wants to give you more rights. So once you, and all the coordination start with your filing only, whatever details available in your filing, all the coordination process and discussion start with the filing itself. You cannot tell that I have the idea, I wanted to change, that you cannot do. So once you are making a filing, you have the broad idea. Then when you are operational satellite, you narrow down your requirement based on the coordination before flying your spacecraft. So first four letter was of your bandwidth of your carrier. Then another four letters are divided into three, four parts. So first part is give you the type of characteristics of your modulations. If you come down to this one, there are some codes are given for different type of modulations. You can see that one, what type of modulation you are implying for your carrier. Then second part of this one is your type of what type of signal modulating main carrier or the signal channel containing optimized digitized information. All those you have to check based on your designer's requirement. So these all emission designator is very important. Once what type of service you are going to provide, because it decides your main carrier side lobes and everything, which is very important when you are going for the coordinations and all those things. And then the different type of services are there. So my mean to show this to you, just you go through and based on that you decide what type of modulations, what type of your frequency, orbital parameters, all those things are required for your requirement. We can come out. Can we go to next slide? Yeah. The third part is the ground station details. Also, you need to file in your system. So already I told you, similarly, this is the emission designator or the power levels. Here, what you have to do when once your almost design is fixed or not, link budget is already you have decided, you need to calculate beforehand to go before going for the filing. What is your maximum value ERP will be there? What is the PFD value of that per hertz and all those details are required here, and what is your required C bar and value will be there. And here also type of modulation carrier, all those things we will see when we are going on the software, how to fill all these things. At the same time, ground station also required your data, what type of gain will be there, then gain patterns, whatever is there. There are some predefined gain patterns are there. If it is not there, then you have to provide in GIMS software, you have to give the pattern and upload type of which part number or number of that GIMS. You have to attach this one to on this one. My main thing here is to once you have decided the frequency, everything, you need to pre-check with your calculation. Does it violates your PFD limit as per Article 21 or 22? So those things you have to do all this exercise to before you start the filing of your filing process. That is the meaning of all my this all presentation. Can we go to next? This is the ground station details. Like you have to give the ground station details where it is there. Here, one part is that you can have a typical, or when you are a specific, when you know your ground station, then you have to give your details. And similarly, whatever you have given for your uplink space station parameters, similar parameters should be matching. If it is not matching, you will get a error from the software. Similarly, your gain and the beamwidth of your, and this to decide your what is the size of antenna you are going to use, and similarly what is the pattern it is going to have. So, or if you are not having the particular pattern, you can use the GIMS database. You can create and attach to this one. So these are all things which is pre-handed required for your making your ITU filings. So now this is the prerequisite to make your ITU filing. So now I will go to the software site and I will just open and how to start filling. Just I will open one of the page and I will show you. And I had one already filled parameters, which I will just show you to how which all parameters are there. Everything is there. So coming, just I will go there and start. I'm audible? So before I go to the software, I just wanted to show you from where you can download all those things. This is simply, you have to go to ITU. ITU, you have to go to the radio communication. And radio communication, if you see, this is the website which is published by ITU and maintained by ITU. So here, right now, our main focus is on the space service. So we will go to the space service from here. And space service, if you go, there are different like if he can preface is there, whatever preface I have shown you, you can download from here. That preface is available, and brick IFIC is also available. So as Amit sir had told, some of these links or some of the resources here are available for everybody without registrations, and some of the resources are available who is having the TIES account, and you need to obtain the TIES account. And some of the service where you need to purchase and you have the subscription, only then you can use. Like if you check the IFIC service, for the checking of IFIC, you require the subscription from the ITU. It is paid service. You need to obtain data. Certain services where you require TIES account from the WPC administrator, that you can use. So right now, what I wanted to show you that on this website, if you go, there are BR software is there. If you click on BR software, here all those software is available, and all this software is captured in the SAM. If you download SAM, so almost all the software listed here you can download at one go. So I have with this this space application manager, I have downloaded and I have installed in my PC to go to this one. So if you go to this one, download it. It is the same. It is downloaded. So this window has opened. So here, if you see, this all softwares is available. So right now, our work is to go to the space cap where we have to capture all the parameters. So already space cap has been opened here in my PC. So I close, I open one. So after clicking that one, you will find this page is open. If you see on the top, it is one is the CRC and notifications. Another is API, which is not the frequency band, which is not required to be coordinated. Then is this is if you see, this is radio astronomy service. Then there are plant band, which is called AP30 appendix, those things. And last one is the your resolution 49, that is called due diligence. So right now I'm going for only for the API, which is as for to understand, it is if you go to all the tabs, it is almost same. And API is the basic of all those things. So I am going for the basic filing only to show you how it starts. So if you tap the API filing, here, if you come to this site, there are the start page is there, Notice Explorer is there. If you are having, if you go here, you can open database. If you have already some database, it will show you which all database is there, or you can navigate through your where you have selected. And if you are already having, you can directly load your database here. Right now, I am not loading this my earlier filing just to show you. So what I will go, I will just go to the new notice so that I can start the new filing. So once you go to the new filing, the first it shows you the notifying administration. You need to firstly select under which administration you are going to have the filing. If you select here IND, it will come IND. And then if it is intergovernmental, if you see the preface, there are some intergovernmental like Intelsat, Emersat, and like Galileo, all those intergovernmental organization is there. Those also being tagged to this software. If you are belong to that one, you can select this one. And here it is that notice submitted on behalf of this administration. Means once you are going for the intergovernmental, then which all country administration you can add to this part of this one. Coming to the second window of this one, here it is showing that either you are having the first time you are going to have this notification. That is the first one, add. If you wanted to modify, if you are already published, you wanted to modify your publication, then you go for the modification. And if you want to suppress your already published, given to the ITU, want to suppress that one, then you go for the suppression. So because I have opened API, so it is directly showing not subject to coordination. So directly you are getting. And because I have not created any beam, so it is showing there is no beam. So after selecting this one, we can go to the beam. So whatever data is there, it is being saved. Here I forgot to this, so that's why it is not going for the next page. So either you have to check when it is not subject to coordination, there are geostationary satellite or non-geostationary. So I'm selecting non-geostationary as of now. So once you are selecting, then you have to tell that either you have to name it your network. You can name it anything because there is some convention given like 8 digit or nine words only you can enter the name. So you can give the any name whatever you wish. It is better to give based on your understanding what name you can give later on. You can see, you can remember easily on those things. And other part is that whenever you are going for NGSO, it can be short duration also, or it is a long duration also. So if it is short duration, the life of your satellite should be less than 3 years, like that of things. So within 3 years, that once publication, within 3 years, you have to bring your satellite. If it is not short duration, then it will be 7 years. Within 7 years, you have to bring the satellite. So this is there. Then number of orbital planes means how many planes once you are making number of planes. Like you can have 1 plane, 2 plane, 5 plane, 12 plane based on your constellation design or number of satellite you wanted to file with this one. Even per plane, 1 satellite you can have, may not be a constellation, but you can have the number of planes in your this one. Then reference body, here you will find where this is, your space station is going to rotate, and which your celestial body it is the over which it is rotating. So generally, when you are using, that is the Earth. So Moon, Jupiter, these are all deep space networks. For everything, ITU has identified as of now. So you can select from here. Then it is selecting it is a constellations or not. If you are not in constellations, then you have to give the phase angle between each of your satellite. What is the phase angle between one to other satellites? So those details you have to provide in constellation. If you are selecting no, those details are not required. And if it is constellation, then number of satellites in northern hemisphere or southern hemisphere at a time, how many are there? Those details you need to fill it here. So after filling all these details, you can go to the beam section. Here you can provide your beam type, what type of beam. So if you go here, if you see there are receive beam and transmit beam. So based on beam, you can select, and then beam designations. This is the naming. It is not the your emission designator. This is the name you have to give. Like if you are having satellite, TC is there, TM is there, or data is there. So you can name it anything. Like your satellite name is new TC1, TC2, TC3. You can name it anything. Then here another part is your it is stable beam or non-stable beam. If stable, you need to check it. And what is the gain of your receive antenna? If you have receive beam you have made, those space station receive gain, what is the gain? It can be 0, 1, 2. Based on your gain, then this will be your antenna coplanar antenna gain pattern for that particular space station where you have given the gain. If 0 dB, you can go for the difference are there. One is ND space. This is all predefined are there. If it is doesn't suit to this one, then you can select. Then it will show you to select the GIMS pattern. From there you can select, or you can give the some formula based also you can give from here. Shall I proceed? Similarly, if you selected this one, then after BIM you have to go to the group. Here group, if you are going, then if you see here, there is one, this filing under ITU, one of the regulation is under 4.4. It is called non-interference, non-protection basis. Means once you are making a filing in non-interference, non-protection basis, generally people doesn't object your filing, but you cannot interfere with others. Once it is interfering, any complaints are coming through administration, you need to shut down your systems. You cannot transmit particularly. At the same time, you cannot expect administration to protect your system, means your frequency filing. So if you are filing under a NINP, means non-interference, non-protection basis, then you have to tick this one. Then I have shown you the service area. You can add service area from here where your frequencies are being beamed in or beamed out. You can select from this one. So if you go, if I select India or something, XIR regions and XI3 regions, I'm just selecting and saving. So if you find it is there, if you want to delete this one, you have to select and unselect from here, you can do that one. Understood? And if you are not having this particular locations wide, like a particular part of only like India, if you want a small part of this one, so you can have the gyms, you can create your gyms and you can attach here for the gyms. At the same time, you have to select the class of stations as we, so based on the type of service, you can drop down and select if you want to have the telemetry, telecommand, you can select. Similarly, nature of service like COs, OT, like that you can select, and then type of polarizations. If you are not sure, then you can use mixed polarization. It contains everything. If you know the type of polarizations, linear, then you have to give angle. CP, then you do not require to provide angles. Because it is a receive beam, so you have to give your noise temperature of your receiver on board. So generally, if you go, it is from 600 to 1200 Kelvin. So you have to provide all those things in this one. So coming to after that one, you have to fill the emission designator. So based on your carrier, what is your carrier? So once that is there, so you have to fill like if you want to have 400 kilohertz or 2 megahertz of carrier, you can give this one. Then your type of modulation, it is a phase modulation. You have to give G. If you are having frequency modulation, F. So you can give anything. Then digital data, it is a digital data is single channel. For that, it is GD. So this type of things you have to provide. And then you have to provide what is the maximum power it is going to transmit. It is the transmitted power, not the ERP. So transmitted power you have to give, and that density you have to provide here. So like this one, you have to fill, and then what type of frequency, what center frequency you are going to. Yeah, please. I will go to, yeah. That already, that time I have shown you. Again, I will show you like that you can find out emission designator. If you go to website, if you here, if you see, I want emission designator. It will provide you the list of options from here. If you give the same document, whatever I have, that time I've given you, there you will find the designator. So here you have to provide you have given this one, you will find sequence number, because another designator, if you are giving, then sequence number 2, 3, 4, it will come. So once you are carrier, you are feeding some carrier like 2025, I am feeding for this one. So it will automatically take one. If I wanted to check like a designator are so many, you can change the sequence here. And here so many frequency also you can fill and save. And here if you see, these all characteristics, whatever you are applying, it is all emission in this group, because I have created single group as of now. So if I select, this all thing will apply to everybody. You need not to enter for everything. So this step, almost I have come to the frequency, then it is coming to the associated Earth station. Similarly, whatever space station you have given, so here you need to select either typical or a specific. If you are giving typical, you will find the longitude and latitude details are not highlighted. If you go to the specific, so it is giving you the country and longitude, latitude details, you need to fill it. And similarly, like ED you have selected there, so you have to select ED here. And type of service I have selected OT. We need to select OT only. If you want to, if you are making a difference between these two, then you will get an error while validating your software. Means your filing, not software. It is filing whatever you are creating. So similarly, you need to give here the antenna pattern of your ground stations. So these are the filings, how you can make the filings. So what I will do, I have not created everything here. So earlier I have created, so I am going to load that filing here so that I can show you what all all tasks you can perform on this software, add, deletes, all those things you can do on those things. So I'm just closing this one. So I'm going to this one, file, open database. This is the one already file I have been created. So I'm opening it. So if you see, I am not able to see if I'm going to other tab, because I have created a file for the API filing. If I'm going to other tab and I'm notice Explorer, I'm going, it is giving some other details which is not mine. It has saved something different because I have already done some other things here. So it is, if you see, it is created today only, and it is known here. So I'm going to API filing, where I have created my own filing. So here I will notice Explorer. This is the one filing I have created earlier. So if you want to make a clone of this one filing, if you are having something you found, you wanted to make a that no, this filing should be remain, and I make a change something. So there is an option here. If you click it here on right side, there are so many details it is there. So if you want to clone, you have to go to clone. You are cloning. So one is already there. So you have to give different clone ID different. You are giving two, and there are all beams you want to do, or certain beams you want to reduce, or you want to change. So you can change from here, select from here, and because BR data, we do not want to what you carry forward. So we have selected no. If you want to carry forward BR data, earlier data, you can select from here. So if I'm creating here, already this notice ID existing, so I need to change it to 101. So if you see, this one is created. So you can, if you are having, you can clone it. So right now, if you see, the both are there. So whatever you have made initial, you do not want to change. You want to do certain changes in this one. So you can go to directly to show, so that here you will get the filling data, whatever you have done. So if you see here, it is showing the today's date. Once it open, it shows the today's date it has done. So here, if you see, almost I have done the number of orbital planes 6. So 6 details are here. There are 6 orbital planes are there. So my reference body is Earth. It is not a constellation. It is an individual satellite in each plane. And my filing name I have given just LBI for my understanding. And these are the inclination angle based on, I thought my all orbitals will have different inclination, time, and apogee, perigee like things. So I have made this one all things. If you see, there are certain bands which required special considerations. So if you collect here, there are some certain parameters that you need to provide, because my data are not pertaining to this one. So I have not filled anything here. So after this one, if you go to the beam, there are groups. So because it has copied, so last all 3 beams I have created here. If you see, there are 2 beams for the receive side and 1 beam for the downlinks, means transmit side. So these all being considered. So if you want, you can directly go there, or you can go through this one. So my all receive beams, whatever is there. So you will find the LVCM 1 beam name I have given. It is the launch, a certain name I have given. It is a command for the command purpose. So my gain is -14, and it is having your coplanar antenna gain is ND space type of, it is a omni type of antenna system. Those details I have given here. So coming to the group, if you find the you will find the notice ID, whatever you have done earlier, all these details you will find here. The group ID is 7. So I have added all these things, and my network doesn't qualify 4.4. So I have not ticked, and all these details I have filled here. Then emissions also I have put. If you go to center frequency, I have 2 type of emission designator, and there are 3 frequency in that one. Yeah, please. Yes. Yes. Uh, yes. See, if you go to the station class, ED is for telecommand, EH4, it is for tracking. So based on that, you can have this one. Both the type of service. That's why I have put that one. Huh? Yes. No, you can make it once you are making a beam here. So if you, this group, if you open, there are 3 beams in this one. So you make another group, there you might be having 5 beams. So you need to create the number of beams, make a group in that number of beams you can create. No, you can make, see, it again depends on evaluation of your systems. If you have made a more number of groups because of your not requirement simply of this one, so ITU process it. If that link is making you to some unfavorable findings, then a lot of correspondence you have to delete, suspend, or suspension, all those things you have to do. So it is a judicious decision based on your requirement.
The reason why I asked you about groups was when you, in designation of emission, you've given, say, 2 planes, 6 M.
Yeah, yes.
That will have to give the frequency range also.
Yes. So if you come to the group and the frequency, if you come, so particular type of service you are having there, like I am space operation I have given. So you are having a total, if you see, you are having around 85 megahertz of bandwidth total allocations, and your emission designator, you are making so many from 1 megahertz to 40 megahertz, even 120 megahertz if you are making. So once you are going for 120 megahertz emission, you are out of your allocations. So it will give you an error. So you cannot make beyond that one. So what I was telling you earlier when I was giving your presentation, that I told you, you have to make a pre-designed or pre-calculation in your, before you go for the filing.
Designation of emission, first 4 letters are for the value of bandwidth.
Bandwidth of your carrier, not the full bandwidth allocated for the operations. Is an emission designator. Yes, that is it. Any other question? Yeah. BIM is basically one carrier. No, BIM is a not a one carrier. It is what you call, it is a designation is given for one carrier, not a one carrier. If you see it here, I have one designation I have given. If you see the frequency, you see the sequence 1 and 2 are there in single beam. I have having 3 frequencies. So this is a beam for this designator. I have grouped one number of beams in one group. In there are 2 frequencies, 2 designators are there. For 2 designators, there are different frequency. If I want to have like one designator, I want only first and second. For the second designator, if I want to remove certain frequency, I can remove from here. So it is what I mean to say is that it is not a one carrier it is a one carrier at a one time. But filing wise, it can have a number of carriers. Yes. So ERP again depends on your frequency and transmitters and gain. It doesn't depends on what frequency you are having. So it is a transmitter frequency, transmitter power is fixed. Whatever frequency you give, it will have the same power. That is density. That is the density, not the ERP. ERP density, that we called EPFD. Did I confuse everybody or what? Did I confuse everybody or what? Okay. So just to this Similarly, Earth Station, these are all filings I have made. Now coming to what we can do on the notice is on this one. See, I have having the beam. I wanted to clone this beam again. One is the full notice you can clone. Again, if you are going to this one, if you want to clone this beam, I wanted to. So there is tool here. Clone it is there. So if you clone, this beam will be again cloned. So whatever your file original is there, if you want to change to that one, you can clone it and you can change that one so that your previous data will be saved there. So here it is a clone. If you want to delete and if you want to rename, once you have cloned, you want to rename, you can rename those things. Then another thing, from here, if you want to you want to make an export of these things, you have done some PC, some folder you want to do to there, so you can go for export of this one. And if you want to delete, then delete buttons are there. And coming to this one being to so here, means tools are there. So you need to explore based on your requirement. So right now, I cannot judge your requirement, so I cannot show you everything. So it is based on your experience, how you are going to use. Based on you can do this one. So as soon as I have done my, based on my understanding, I have filled everything proper, everything I have done. So this software, what you can do is, you can just to I have created this one as this one. I have not changed, similarly clone. So you can go for the validation. Understood? So if you go to validation, what validation I told you, it just check with respect to the frequency table of allocations, EPFD limit, and your for the filing, making the MDV file, whatever the characteristics as per preface, like it should be a 3 character, 4 character, or some mismatch, that it will give you. So once you go for the validations, it will give you the result. What is the problem in your filings are there. So here it is there. For my this filing, I have not created any gyms, so I will not add any gyms. If you have, if you, in your filing you have added gyms, so you have to browse and check. You have to add the gyms software here and then validate your software filings. So if you see here, you after this validation, because it has not gone for the link performance analysis that is done by the ITU once it is submitted, you will find there are some changes. Based on this one, there are fatal errors, there are some warnings. If fatal error is there, ITU will, e-submission portal of the ITU will not accept your MDV as it is. So you need to remove all these errors. If you check, it is showing that orbital plane is not associated with any beam. So you need to find out which, like value for orbit, it is there. Some if you click, it will show you where is the problem, which one. Like each orbital plane must be associated with last one beam. So that is not there. So that's why that error is coming. So you need to attach this one. If you go to the this one, if you go here, you can directly see the print. It will show whatever you have made a filing. It will show a print. What file of this one. There you can create a document. for all the beams. So if you see here, I have created the 3 beams. And here I have the 6 planes. But if you see for this beam, first beam only, first 3 planes only I have given. So, and the second beam also, first 3 orbital plane I have given. And the third beam also, first 3 orbital planes I have given. So 4, 5, 6 beams, for the 4, 5, 6 orbital plane, I have not associated any beams. So that error had come. So you need to associate all those things. All the orbital plane has to have some beams. So that's why that error is there. Similarly, other warnings are there. So you need to explore all those things and change that one. Clear? So I will stop for this one for today. So I will go to other section of IFIC, how to check IFIC. Shall I proceed? So this way you can make a filing. Once you have made a filing, you need to submit it to your administration, and administration in turn will submit to the ITU. Once it has gone to the ITU, so we will go to the ITU website to check how to check my filing or others filing from here. So if you go to the radio communication space, then SNS, Space Network Service, here these are hopefully free of cost. You can directly go. Here if you see notifying agency, if you type, you will find all the satellite network of India, which has been filed. So you can find out from here. And here there are so many things. Either if you know that networks, directly you can see directly networks whichever been filed. Like Aditya, if you say Aditya, what all filings had been made with the ITU, those details are available. And what I wanted to show you the different things. I wanted to show you the IFIC. So IFIC, how it looks. So this is the paid service. So once you go to the IFIC service, you need to have a login. It is a paid one. So you need to take a subscription of this one. So once you are going, earlier it is coming in the CD form. Now it is the totally digital form, and you need to take a subscription, and from there you can see. So it is showing the publications, whatever we made last 4, 5 years. So latest publication, if you see, that is the last publication is 3068 Break IFP, and it is published on 31st March. So you need to open this one. Once you have selected, you come to the publications. So it is showing all the publications which had been made in the 3068. They are AP30 publications. Then this you see that plant band broadcast type of service, then API publications which we are making. Once you open this one, see how it looks. Once any publication is there, so whatever you have published, this is the network of China and GSO constellation. Those things are there, and it is identified by API number 14299 and which IFIC it has been published and which date. So any network in the ITU been identified by the publications and the IFIC type. So based on this, you can see here. If you see. So if you see, it is published under the details, whatever if you see, it is, if you read this one, it is published under Article 9.1 and 9.2. So any publication, any details ITU giving based on the 4 volumes of the article only. So this has been published under Article 9.1 and 9.2. So if you see the details here, it is showing the what is the name and which country it is there, administrations, and then the date it is received by the ITU, though it is published in March, but had been received by ITU in December. And then it is showing the number of beams and all those beams details it is showing, and type of station class it is showing. Then number of orbital planes you can find out from here. So, and what all details like E3 is the sensor types. So what are all details had been provided here. You can see everything here. That is noise temperature 500 Kelvin, then validity period 50 years, and type of service, if you see which all plane it is applied. So all details you can find. So major objection, what we generally find it from the frequency band of operations and the service area where it is going. So if you come to service area, that service area, either they are notifying here the details, or they give the GIMS software, because this is a active sensor type. So those details are not the active passive sensors. So these are the ground station details. Whatever we are filling, those details are available. So based on this, we need to find out, we need to object it, or we need not to object it. It is contradicting with our networks. So all those details you will find on this one. So these are the antenna details which is added in GIMS. Either you can select from those predefined pattern, or you can give it from here. And so because the country service area, see here service area, all details are there. So if you see XAX means it is full globe, it is there. So if frequency is colliding with you, you can object this one. So based on this, you can decide on all those things. So hopefully I am clear till a certain point of time. I stop from here, and any questions, if you are having any questions, you can ask me. Okay. Yeah. If you see that one, once you are giving the satellite orbital parameters, if you are having the constellations, if you select the constellations, then it will give you the phase angle between the satellites in a particular orbit. So that details you have to provide, like from the particular one satellite to other satellite, what is the phase between each one in a particular orbit. That is called your satellite position in the orbit.
Suppose we have a two cells. One have a 1 degree of phasing angle, another have a 7 degree of angle.
Yes.
So how we will configure in this spacecraft?
No, if you are phasing angle of 1 degree, then you are having more than 360 satellite in a orbit. So that's why you have to give if orbital parameters in one orbit, you are telling that 360 satellite in a constellation, it is there. So you are giving an orbital apogee, perigee, then phase angle between the satellites. If you select the constellation, that window will be activated. So in that, you have to give all these details.
One question is how to find the orbital separation in between? How to configure the orbital separation in that spacecraft?
Orbital separation in space cap.
If I want to configure orbital separation in terms of RAN.
RAN. That's why. That is what phasing, whatever you are telling. Na? Between, if you are having a one orbital plane, you are going to have around 10 satellites. Then you general procedure is it is equi-placed. So 360 degree divided by 10, 36. So you plan with the 0, 36, 72 like this one. You are plan. That is your configuration constellation designing that you need to find out based on your orbital parameter or your applications. No, it is your orbital. ITUs never calculate if off its on. Once you are submitting, then it check your parameters. It is with line with the ITU understanding of their conventions, and then based on that, it checks your link design. It never checks that it should be in equidistance or equiplaced. Right now, I don't have. It is based on simply, sir, whatever EPFD, the ERP density. So once you know the ERP, like you have the carrier of 1 megahertz, and your transmitter is having 40 dB, 40 dBm ERP, 40 dBm of transmit capability, and 20 dBi for antenna. So total ERP becomes 60 dBm. So if you are having 1 megahertz carrier, so 1 megahertz around 60 dB. So 60 by 60, you are going to get 1 dB per hertz type of thing, dBm per hertz. It is simple calculation, what I believe so. Hope that is the only question of yours, or it is different. No, that's. No, once it is come to NGSO, it is the cumulative or effective EPFD value. It is not from the single satellite. So whatever I told you, it is from the single satellite. Yeah, there are paid tools is available, and that is Visualize software, and other is I forgot name. There are two. One is Visualize, another is some two companies are there. Huh? These are paid tools. And these two service providers only provided the tools to the ITU for all these calculations. Yes, yes, you need to do. Otherwise, you will be coming to the non-favorable findings and it will not be published.
I have one more question. Actually, we have a multiple carriers frequency. So for the ITU filing, we have to separate for the separate band, or either we can go in one way like a K band or KU band.
No, I have shown you the last. If you see, there are C band and S band, X band. So it depends on type of filings and what type of coordinations. If it is coming into frequency band in coordinations, then you have to make one filing. They're all filing, all details you have to provide. But again, it is ITU, once they are doing this CRC examinations, it is doing based on the number of carriers you are provided to the ITU in filings. Whereas API and all things, it is very simple for them to file, do this one. So their charges are not based on each frequency wise, not carrier wise.
So we can go on one way, right?
Yeah, you can have. So, but only thing, it should not intermix with the API and CRC. You have to check the frequency which are coming under CRC, which are coming into API. So that segregation you have to make while making a filing. Like you are a satellite having multiple frequency, which are falling under, one is API, another is CRC, another is AP30B or 38 type of things. You have to make different filings. If frequency belongs to the different allocations under the ITU. Shall we conclude now?
Add on to what was being said. So do not mix an API with a CRC. Even you can have more than API filings, you can have more than one CRC filing, but do not mix with each other. And just to clarify, one space object can use multiple, can bring into use multiple filings. So you do need not make one filing. So if you think that you missed out on a parameters, you can make another filing. But the disadvantage of making filings separated by 6 months or 5 months, that you lose seniority. So once you design the whole operator characteristics, make sure that you file at once. 3 filings at once. If you make a filing after 6 months or 1 year or 2 years, you lose your priority, your seniority. No, I said you try to make one filing. So if your space object uses some certain frequency band which are subject to coordination, and use certain frequency bands which are not subject to coordination. So not subject to coordination will be an API filing. So you make one notice ID with an API filing, make another notice ID with the CRC filing. You send that all these 2 filings to us together in one bunch. Not merge the MDV filing. You have 2 different MDV filings. And we will file it on the same day with ITU. Say for instance, you forgot to mention certain frequency band. You thought, okay, I will put one more functionality in my space object. And you remember that one more year after that. You make another filing and send it to us. You lose a year of seniority, right? So you may not be able to use that frequency range when you put your space object. You may have to wait for the coordination process to finish.
Take few questions which I have received online. I'll read out. If it is API alone, no coordination required. In that case also, do we need to provide all these details in the SpaceCap software?
Yes, filing is, for the filing, all information is required to ITU to register your space object. So without information, your space object will not be registered with the ITU.
Another one was our API filing is done in amateur band. Do we also require to do CRC filing further? I think no. We go to other one. For satellites with amateur service as primary purpose, do we need to do the ITU filings? If yes, do we need to give the details of each antenna beams?
Yes, any ITU filing if you are doing, it is information you are providing you to the ITU for registering your frequency band and your satellite network. So whatever information want to operate and you want to coordinate with take the support. Now it is become strict. Other networks have become very strict unless it is their service area is being notified or not being there in the ITU filing, they will not provide you the service. So if you want to take the service of certain area, those administration has to be included in your filing. So if certain frequency band, if you miss in the filing and want to take service, those administration can deny your service in that area also. So it is better to file whatever you are desired and what is your intended to have a service, and whichever administration or whichever area you wanted to use your frequency to be operated. So you need to provide every details in that ITU filings.
One BR-IFIC application has all the details of the ITU filing. If we are going for an uncoordinated band, then do we need to have this application? What is license cost? I think license cost will reserve for you. Can
I would like to add here. So for amateurs, there is no license fees and there is no royalty to be paid. Making a filing with ITU and successfully coordinating that resource and entering into the MIFR does not guarantee the right to use the ground infrastructure. The space object might beam onto Earth, but you cannot use that on the national territory. For that, you need a license. So you need to follow the regulations, the guidelines, and the licensing policy of the Government of India. For that, you need to specifically look at what frequency band and for what service you are want a license for.
Since you have the mic, I'll put another one related question. For a company which doesn't have a satellite, can they access details from ITU of other satellite for their studies or to aid the development of their products? So how other entities can access the resources of ITU even if they are not a satellite operator or are not operating the satellite?
Well, you can always request for a TIES account. You need not be a satellite operator to be getting a TIES account. Even for a research institution, there are many research institutions having a TIES account. So they have access to the ITU database and all the resources. They can go for that.
No, adding to the Amit sir, if you, I have shown you the Explorer site on the ITU. There it is without the subscription, and you can directly see there all the satellite details. Typing the type of satellite which you want to see, you can go to that Explorer site in ITU website, and you can see all the details of those things.
You can add on how they can part of these ongoing studies. Something you would like to add?
That you forget.
There is another question.
Yeah, one question is there, sir. No, I didn't get your question.
There is any mob or method of procedure to filing procedure?
Yes.
I'm OP for this. So there is available or online or
No, if you go to ITU website, there are so many tutorials. ITU itself is having so many tutorials. If you go there, so you can see the tutorials and you can learn. And at the same time, you can contact the InSpace. They in turn will provide you the solution, or they may contact us to provide you the support for your to file.
I'll take some more are there. If you are,
no,
ma'am, can we take few more questions or
no?
We can. Fine. Okay. We'll take.
I am certainly other meeting.
Okay, we'll take three more. Maybe we'll stop at three. So
no, I will take.
Does ITU authorize approve our orbital slots as well?
No, ITU doesn't authorize. It is just a registration of your requirement. So ITU doesn't authorize. It is only provide a framework to you need to coordinate. It is a framework. ITU doesn't provide any authorization, and neither it is a enforceable type of things. It is based on best practice and the best coordinations and best ethical practice. So ITU doesn't provide you any what you call right to use anything.
And if you can add on the plan and orbital slots that are
Plan band.
It will complete the picture.
So I don't know. I will be exceeding the things. So right now, whatever you have seen on the filing coordination and non-coordination. One is in coordination also. Generally, whatever frequency band for the communication purpose. Certain once in WRC, I remember 7, not 7, 99. If Kevin can agree, plan band concept had come in 90s. 85. Oh, yeah, 85. It is plan band concept has come. What was the issue that many of the advanced nations had filed all around the world? There were certain international networks. We had filed for the communication satellite. They have around the world, and the new entrant, the developing nations and the underdeveloped nations, they wanted to come into the satellite communication side to have their own networks. So the frequency band in the communication satellite has been bifurcated in two. One is the normal band, another is the plan band. What ITU has done, certain part of frequency band in the particular service had been allocated to the particular country from the particular slot. and particular service area, and emission designator, and service contour, and type of your carrier, they have defined it. So those bands are called the plant band, and that is coming under appendix AP30. So in that, there are two type of service. One is the fixed satellite service, another is broadcast satellite service. So for AP30 and 30A belongs to the broadcast service, and AP30B is for the plant FSS service. So for a particular country, it has been allotted. Like if you see India has been allotted around for the BSS service, broadcast satellite service, at 55 and 68, and plant service at 74. If I am not wrong, I need to check.
I think it's covered in Amit sir's slide also. So,
similarly, every country has been allocated similarly. So that becomes the plant band, and it is a particular nationalized service for the requirement of those developing country, for their strategic use, for their special purpose, or for coming to their in space satellite service. So these are called plant band.
I think that you summarized it. So ITU will provide allotment. No? And one last question, I think it will be relevant. If ground stations are not fixed by the time of API submission and later requirements came for adding stations, what can be done?
Generally, see, there are options I've told you. There are typical stations you can put. So once you are putting typical station and the service area XAX, it means covered all. But right now regulations are becoming too harsh. I have seen some of the country objecting if their service area is not added, then they are not providing service. It is better to what you call pre-plan, add. Let the objection come, then later on you can remove, but better to add all those service area and those countries.
Another one is,
Suppose we completed the ITU filings, and in the further development stage, we found that there is some parameter change or some antenna gains will be retuned, or maybe that orientation or beam forming will be changed. So in that case, we have to reprocess the ITU, or
no, that's why I told you, if you see the first page of API filing, there is add, modification, and separation. So you have to go for the modification filing, mod filing for that purpose. No, general modification filing.
So every modification that due in the filing will restrict your parameters even further. So that you have to keep in mind. You cannot increase the parameter size, whether it's frequency or emission or bandwidth. You can't do that.
The relevant question may be the priority date, whether that will also change based on the date on which the modification is done.
So if every modification results in reduction in parameter size, that's fine. Your date of receipt remain the same. Right? Date of receipt is when the moment I submit to ITU, so that decides your priority, that decides your seniority. So if you have a modification which would like to increase the frequency, sorry, you will have a new date of receipt and reduce priority. Right?
For ground station, do we need to reach the authorities separately?
Yes, it depends on the every country, their regulations for the use to their ground stations. No, even for the other country also they are asking for this one authorizations.
Can satellite be launched without coordination if the API CRC process is still under progress? In this case, in space, NWPC.
No, you answer it. If your question, you have to answer.
Well, the answer is yes, as he said, but there's no way you can use the resource. Right? The satellite will keep on moving without beaming anything.
Correct. So as sir told, if all are in agreement, we may consider the case based on the merits of it. Yeah. So there's a last question I'll take. How does ISRO submit launch vehicle clearances and to which body, national or international?
No, any space object which is flying more than the 100 kilometers, it is come under space objects and it need to be filed. So ISRO is also filed for the launch vehicles, and it is similar to the space object, any other space objects. Thank you.
We have completed. Thank you, Himanshu.
Yes, he actually deserves a big round of applause for that step-by-step tutorials. Thank you, Himanshu. That was engaging. So we have finished the question and answers and interaction round also. Now we would like to honor our resource persons for sharing their technical wisdom today. So may I request again Dr. P.K. Jain to present the memento to our resource persons as the modest gesture to thank them. Yeah, may I request all the resource persons to come in the front? Amit ji, Nitin ji, Himanshu, Vinay, you can join. आइए सर. Group photo, yes. We have come to the end of today's workshop. I am privileged to propose a short vote of thanks. It has been an incredible productive day. My profound gratitude to Honorable Chairman ISRO and Chairman InSpace who provided the vision and trajectory for this workshop. My sincere thanks to Scientific Secretary, Director ISTRAC, Director PMA InSpace, and Director SCNPO for their guiding presence since inception of this idea of workshop. Our resource persons from SSOMA, ISTRAC, have curated their presentations with immense care, distilling years of operational experience into their sessions. They have ensured that today the audience walk out with practical and actionable knowledge. Resource persons from AMSAT India, WPC, SCNPO, and InSpace have demystified the ITU framework. The sessions were enrichingly helpful, and the Herculean task of making an ITU filing is looking achievable now. Thank you for your dedication to excellence. Special thanks to the organizing committee of ISRO and InSpace for their planning and indispensable support. My heartfelt thanks to the distinguished audience, online and offline, for their curiosity and active engagements. My gratitude to unseen heroes, the IT team, technicians, catering people, housekeeping, and support staff for their tireless efforts. So let's make the space safer, sustainable, and interference-free. Thank you so much. Have a safe travel. This is my real pleasure. Thank you. Thank you. Have a nice evening.